Hello guys and welcome to today's session. Today we are going to talk about Win32 app deployment via Intune. And guys, as you can already see, I'm calling this one the real game changer. This is going to be one of those longer ones and I have no intentions of cutting it short. I mean, please get your cup of coffee and make sure that you are in for a real treat here. I mean, this is something which has been which I've been planning to do since very long, and Win32 app deployment, I mean, opens up so many avenues as far as managing a Windows 10 device is concerned via Intune. This is something which was really needed and now it is possible. So let's just get right to it. Let's just take a look over today's agenda, and we have a packed session. So this is what we are going to discuss in this nugget. We're going to talk about what is a Win32 app and why do we need it? What are the prerequisites? What exactly is Intune management extension? What happens during the delivery of a Win32 app deployment? How to prepare a Win32 app? How to deploy it? What happens under the hood as far as the delivery is concerned. The processing, will take a look over a couple of logs, we'll take a look over the registry location, and then we will take a look over some customized use case scenarios, like if it is not an exe that we want to deploy, if it's a specific KB, then how do we do that? How do we set up dependencies? How do we use Powershell scripts for detection logic and all that? We'll take a look over common errors and then we will go into the demonstration. A lot of this is available in our official documentation. However, I mean, the official documentation as of now mostly contains how to set up how to create the Win32 app file. I mean the Intune Win app file and how to deploy it. But as far as analyzing the logs is concerned, that is something that we don't have in docs.microsoft.com yet. So probably this is wherein this nugget might fill in the gap. Okay, so let's just get started. The very first thing that comes into our mind is what is Win32 app deployment and why do we exactly need it? So guys, let's just do a rewind probably 2 years back. So back in 2018, we did not have the ability of deploying a exe via Intune. Okay, so if I have a VLC media player exe, well, again, VLC media player is something which is available in store, but let's just say there is a LOB application and we have the exe file, or there is a file, there is an application which has .msi. So .msi is something that we could inherently deploy via Intune as a LOB application, but exe is something that we could not. Now, given that we were heading into a co-managed scenario wherein, let's just say, a device was being managed via SCCM as well as Intune at the same point of time, then it brought up a very logical question that, well, if the workload for app deployment is moved to Intune, and if Intune is to manage the device as well as the app deployment in the device, then how exactly do we cater to deployment of a exe? Because, well, most of the LOB applications, if not all, might be in the exe format, right? There were also instances wherein we wanted to deploy a package or wherein we wanted to set up something like a dependency. So when I say a package, I mean if you're from an SCCM background, you might be familiar with the packaging, which is possible via SCCM. But back till 2018, deployment of a exe and deployment of a packaged file was something which was inherently not possible via Intune. I wouldn't really call this a drawback, but it was a roadblocker, right? It was a blocker for us. So hence we introduced the concept of Win32 app, wherein we could deploy exes as well as packages as well as multiple MSIs to devices via Intune. However, there was something that we had to first do, after which the applications could be deployed. Okay, So what is it that we had to do is something that is that will follow. But for now, just know that, well, inherently we did not have the option of deploying exes, multiple MSIs or packages, which we can via SCCM. And now given that, well, we are trying to achieve more or less the same thing via Intune, which we could via SCCM. So, well, it would only make sense that if we came up with a solution to this roadblock. So that is what the Win32 app deployment is. It enables us to deploy scripts and packages and exes, and we can deploy a specific driver, a specific hardware, a specific patch to a device. So if I want to deploy a specific patch to a device, that is inherently not possible from Intune, right? Because I mean, the update ring that we make, we cannot select a specific patch that needs to be deployed. However, in case of SCCM, we can do that. We can cache the patches and then deploy those patches. However, if we still need to do this via Intune, then the way to do that is not via using Windows update ring, but by using the Win32 app deployment method, which we will see how. And if there is any specific driver, any specific hardware, any specific software that needs to be deployed, any package, again, as I said, any exes, then this is when it fits into the picture. Now we also introduced something called a detection logic, which inherently was not there if we talk about any application apart from a Win32 application. So what detection logic brings into the table is first we detect whether a specific application is present in the device or not. If by using any specific kind of detection logic. So let's just say that I want to install Google Chrome onto the device. So first I'm going to detect whether Google Chrome is already installed in the device or not. There are many ways of detecting it. I can actually go to C drive program files and then see whether the folder that needs to be created once Google Chrome is installed, whether that folder is present or not. I mean, that would actually be a folder level detection. We can do a file level detection. We can do a registry level detection. There are lots of detection that we can do. But long story short, what I'm trying to say is, if we are deploying a Win32 application, we can use something called a detection logic. What it does is, we can first set a detection only if that detection is not met. Meaning, I have set a detection for Chrome. Only if Chrome is not detected is when Chrome gets downloaded into the device, Chrome gets installed in the device, and once Chrome is installed, the same detection logic is evaluated again to see whether after the app deployment and whether after the app installation, whether now the detection logic detects the presence of that application or not. Okay, this is something that we inherently don't have in any other app deployment method. So if we are deploying any suite or if we are deploying any store app, we cannot specify a custom detection logic. Okay. We also introduced something called requirement rules. Again, this was also a good addition. So now let's just say that I have deployed the Chrome application. So I have the ability of deploying, for example, let's just say Chrome application, Google Chrome application via two ways, right? One is obviously from the store because Chrome is available in store. And second is as a Win32 application wherein we will be deploying the exe of Chrome, right? The setup file. So if we do a comparison between the two methods, then probably it will give us an idea as in why this Win32 app deployment approach is better, if I would call it. Well, I will not really say easier because it's very easy to deploy a Chrome application from the store. However, if we want to deploy that Chrome application as a Win32 app, there are a couple of steps which are involved. However, it is better because, well, obviously the first thing is we can put in a detection logic. The second thing is we can put in something called a requirement rule, wherein I can say that if the device has 100 MB free space in the C drive, only then install this application. Or if the device has 1 gig free RAM, only then install this application, or any custom requirement rule. Okay. So this is again a value add. We did not have this in a deployment via store application. And finally, we had an option of setting dependencies. This is again a very major addition because this changes things a lot. So inherently via Intune, we don't have the option of assigning priorities to any profile. What I mean by that is, let's just say there are 4 profiles deployed via Intune. Okay. Those 4 profiles can be 4 different device configuration profile, or those 4 profiles can be something like 4 different applications. Okay. Now from Intune, we don't have the ability of saying that, you know what, out of these 4 applications, the first application A should get installed first, and then application B, and then application C, and then application D. Okay. What it means is application D should not be installed unless and until A, B, and C are installed already. Okay. Similarly, if we have something called, if we have a configuration profile. So if we had 4 configuration profiles, we inherently don't have the option or ability to say that, you know what, out of these 4 profiles, first the device configuration profile should go, and then the SCEP profile, and then the trusted profile should go, and then the SCEP profile should go, and then the Wi-Fi we don't have the ability of setting a priority, as in this is priority 1, this has to go first, and then this is priority 2, and then this is priority 3, and if one is gone, then the other should also go or should also not go, depending upon what the use case is. I'm bringing this up because this is something that can be inherently done via SCCM. Okay. So this is something that we inherently could not do via Intune. However, as far as app deployment is concerned, there were many scenarios wherein we actually needed this a lot. So we did not want the SCCM client installed in the device unless and until there was another dependent software which was already installed in the device. We did not want application B to be installed unless application A was installed already. Inherently, this could not be done if it was a store app or a LOB app which you were deploying as a normal MSI. This could not be done. Or if it was a suite, still it could not be done. However, with Win32 app approach, this is a major add-on, and now we have the ability of setting up dependencies. What that means is I can set up the deployment of the Win32 application in a way that I can say that, you know what, app A is dependent on app B. What that means is, even if we have only deployed app A, even if we have not even targeted and deployed the app B, but when we are deploying app A, we have made this dependency of app A on app B, then automatically app B will be installed on the device first. Once app B is installed and detected, only then app A installation will start on the device. So this is another advantage of doing a Win32 app deployment. It lets us set up dependencies. Again, there might be some gray area regarding this, so we will take a look over dependencies in detail. We will take a look over this during the demonstration as well. But I hope that this gives us a perspective as in what exactly Win32 app is and why do we exactly need it? Where exactly is it filling in the gaps? Okay. Now we are going to talk about the prerequisite, and one of the most common thing that we have to keep in mind is a Win32 application cannot be deployed to a device which is either this, that is, which is only enrolled to Intune, or which is Azure AD registered and enrolled to Intune. So if we have a device which is Azure AD registered, and then let's just say the auto enrollment was set, then the device will automatically be enrolled to Intune, right? Win32 application cannot be deployed to that. Or if we have a device which is only enrolled to Intune and does not have any record of that device in Azure. How do we do that? We do that by going into start settings, access work or school, and instead of clicking on connect, on the right hand side there is that hyperlink which says enroll only in device management. If we have done that, what that means is the device is enrolled to Intune, but there is no record of this device in Azure. So if it is either of these two use cases, then we cannot deploy a Win32 application to the device. What it means is, it means that if the device is Azure AD joined, so the device can be Azure AD joined manually, or the device can be autopiloted. Doesn't matter how you are Azure AD joining the device. If the device is Azure AD joined, and well, obviously if the MDM scope was set appropriately, then the device will get enrolled to Intune as well. So if the device was Azure AD joined and enrolled to Intune, then Win32 application can be deployed to the device. Or if the device was hybrid Azure AD joined and enrolled to Intune. What I mean by that is, if we have a setup wherein, I mean, the most common example of this would be if we have an on-premise setup, the device hybrid Azure AD joined means the device is joined to both on-prem as well as Azure, right? How do we get a device hybrid Azure AD joined? Usually by using Azure AD Connect tool. Okay, so when you're using the Azure AD Connect tool, you can select that checkbox which says devices should be hybrid Azure AD joined. Okay, if that is done, then after that the device can be automatically enrolled to Intune using the SCCM client, which would make it co-managed, or using a group policy. No matter how you do it, what I'm trying to get at is, if it is only enrolled into device management, or if the device is Azure AD registered and joined to and then enrolled to Intune, Win32 app deployment will not work. The device needs to be Azure AD joined or hybrid Azure AD joined and then enrolled into MDM. Okay. As far as the OS prerequisite is concerned, it needs to be Windows 10, 16 or 7 or later, and the variant can be Enterprise Pro Education either. Okay. All right. So until now we have spoken about what Win32 app is, why do we need it, and what are the prerequisites for installing a Win32 application, that the device needs to be Azure AD joined or hybrid Azure AD joined and obviously enrolled to Intune. Now I want to take a moment here and then talk about IME. IME stands for Intune Management Extension, and Win32 application has a dependency on IME. So the best way to explain what IME is and why do we need it would be like this. So I mean, back when we were the first thing that comes into my mind is back when we were working as a server administrator, and then we had data centers all over the globe, right? So now as a server admin, we are getting a prompt, or we are getting an alert that, you know what, in this server this drive has failed, or this RAM module has failed, right? Well, obviously we are working, obviously I was working from offshore. We needed somebody to go into that data center, pull out that hard disk and replace that hard disk with a new one, right? Usually the way we did this was either getting in touch with the local site team or raising a case with MainTech. So MainTech is a third party which would usually go to the data center and get this done for us, and we called them our remote hands. Okay, what I meant by remote hands is, we used to call them up, tell them that, you know what, this is the server, this is where it is present, this is the serial number, this is a hard disk which has failed in this bay. You need to get a hard disk of 250 gigs. Just go to this server, pull out the old one, insert the new one, and then I will monitor from my HP array configuration utility and let you know that whether the RAID is built or not and whether the hard disk is showing fine or not, right? So in this entire scenario, you can think of the hard disk which the MainTech guy is going and inserting into the server in the data center present anywhere in the globe as the Win32 application. And the person who is doing this, the MainTech guy, is the IME. Okay, so IME is, you can think of it as an agent or our remote hands. So now let's just try to compare this analogy here. Over here, Intune service is me. Okay, I am the Intune service, meaning I am saying that there is a device over there and that device needs a Win32 application. Okay. But how do I remotely deploy that Win32 application to a device present anywhere in the globe? I take help from my remote hand, which in this case is Intune management extension. So I coordinate with Intune management extension and I tell Intune management extension that this is the hard disk that you need to replace. This is the RAM that you need to replace, and Intune management extension does that for me. Okay. So I hope that this analogy makes sense. So we will see that, I mean, just like I am coordinating with the main tech guy, calling him, I'm couriering him the package that I'm couriering him the RAM module, or I'm sending him the hard disk. Similarly, Intune service will be sending all that information to the Intune management extension that is in our remote hand. And Intune management extension is the agent, or in this case you can say is the person who is doing that job of replacing the hard disk for us, which in this case is doing that job of installing the Win32 application for us. Again, when I'm saying that Intune management extension is going to install that application, how will Intune management extension know how that application needs to be installed? Well, the answer to that would be the similar way the Mintech guy knew how that hard disk needs to be inserted, right? And which hard disk needs to be inserted, right? So I'm calling the Mintech guy and telling him that this is the way, this is the configuration of RAID, this is the configuration of the hard disk, this is the one that you need to pull out, this is the one that you need to insert. Similarly, over here also, we are going to tell the IME, this is the app that you need to install, this is the installation command, this is the uninstallation command, this is the dependency, this is the detection logic. IME is just going to implement that for us. Okay. So I hope that this analogy now makes sense, and now we are clear on what exactly Intune management extension is. It is nothing but our remote hands. It's an agent that we are installing on the device so that these tasks can be performed. When I'm saying these tasks, what I'm referring to it is installation of a Win32 application or installation of a PowerShell script. That is any PS1. So if any PS1 is deployed via Intune, or if any Win32 application is deployed, both of them are going to utilize IME, which is the agent. Okay. All right. So now let's just talk in a little more technical terms. The other word for Intune management extension that we might see is sidecar agent. Okay. So sidecar agent also refers to the same person as Intune management extension, which is in our case remote hands. It's doing that configuration for us. So IME is our remote hands at the device, and we give it the application and the commands. IME executes it for us, right? We tell him what to do, how to do. IME will do it for us. If it is not done, IME will let us know that, you know what, you told me to do this. This is what I did. This is what was successful. This is what was not successful. And this is how I determined whether it was successful or not. Okay. The Intune management extension supplements the built-in, it supplements the inbox Windows 10 MDM capabilities. It is a client-side component which is installed on all the Windows 10 devices, and it is used for Win32 application deployment as well as PS1 deployment. Okay. We don't need to deploy a IME. So IME agent does not need to be deployed. We just need to deploy the Win32 application to a user or to a device, or we just need to deploy a PowerShell script to a user or to a device. Once we are deploying that PowerShell script or Win32 application, IME will be installed first automatically. There is nothing that needs to be done by us to install the IME. Just like when we are calling our, replacing that hard disk, right? I mean, we raise a case with Mintech and Mintech takes care of it, right? Takes care of the hard disk swapping. Similarly over here. And then IME agent, there is an IME agent that gets installed. We'll take a look over how that agent looks, where can that agent be seen, what is the service that is running for that agent, what are the registry locations. We will see all of that. And IME agent checks with the Intune service once every hour and after every reboot for any scripts or for any changes. What that means is the main tech guy is calling me every 1 hour and it's telling me, is there any hard disk or a RAM that you need replaced or a motherboard that you need replaced? So it's doing that heartbeat check with me every 1 hour to make sure that if there is anything that I need, I should let him know so that he would do the same for me, right? Similarly, IME over here is checking with the Intune service every hour and after every reboot. And if there was any new Win32 application that was deployed or any changes were made or any PowerShell script that was deployed, it will grab that policy body. So IME agent will grab the policy body from Intune service and then it will do the needful. And then there is a service called Microsoft Intune Management Extension that gets, that is the one that is responsible for all the processing with respect to IME. Okay. So, if you have seen a certificate deployment via Intune, you would have seen that there are 3 folders, right? One is incoming and then processing and then succeeded or failed, right? So similarly, we have the same thing in IME agent as well. So just when a Win32 application is getting downloaded, it will first come to the incoming folder and then it will move to staging or stage and then successful or succeeded, whatever the case may be. Okay, so these are 3 working folders that we have. Again, we will see all of this during the demonstration, but just for us to know that there is a folder that gets created called under C drive program files called Microsoft Intune Management Extension, and inside of that there is this content folder wherein the content gets downloaded and installed. Okay, so you can see that both these folders have the same timestamp, meaning that the file first would have come to incoming and then it would have probably moved into staging. And okay, so let's just say that IME agent how do we actually know whether Mintech has reached the data center or not? How do I know that? Well, I can just call him and ask him. That is one way, but there are some other ways also, right? I can call the receptionist and ask him that, you know what, is there anybody from Mintech in that site or not? Similarly, how do we find out whether our remote agent, that is Intune Management Extension, is installed in the device or not? Because until and unless Intune Management Extension is installed, the Win32 app will not go, right? Meaning until and unless Mintech guy is there on the data center, the hard disk cannot be replaced, right? So that is why we first have to make sure that Intune Management Extension or the Mintech guy is there at the data center, right? So how do we make sure that the agent is there? Well, there are a couple of ways to do that. We can see in the start menu, we can check the services, we can check the MDM diag report, and we can check in the control panel. So if we are going into start settings, access work or school, and then we are clicking on info, and this is from where we run a sync, right? So below sync, if Intune Management Extension is installed in the device, then over here we will be able to see that Microsoft Intune Management Extension under applications. So it just shows up like an application would show up once it is deployed and installed, right? We can see it in the MDM diag logs as well. And we can see it in the services and in the control panel as well. So if I go to that Windows 10 machine, if I open up the control panel appwiz.cpl, then over there I can see that there is this Intune Management Extension which is installed in the add remove program section. I can also see that there is this Microsoft Intune Management Extension service that is running. It should be set to automatic. And if I go to start over there also, I can run a search for Microsoft Intune Management Extension. So this is how we can conclude that, okay, we did not have to do anything in order to deploy this Intune Management Extension. All we did was deploy a Win32 app or a PowerShell script. This got installed automatically, okay? And how do we confirm whether this was installed automatically or not? This is how we can confirm. This is wherein we can check. So, the most common use case for this would be, let's just say we have an issue wherein a Win32 application is not getting installed in the device. Well, obviously, if a hard disk is not, if I raised a case yesterday saying a hard disk needs to be replaced, Today I'm logging into the server and I'm checking that, you know what, hard disk is still showing as it's still showing the amber light. It is not showing the green light, meaning it is still failed, right? So what is the first thing that I do? Well, the first thing that I do is I find out whether the main tech guy even went there or not, right? If the main tech guy went there, then that there is a chance that he would have replaced it or he would not have replaced it, right? But for either of those cases, the main tech guy has to go to the data center first, right? Similarly over here, if Win32 application is deployed to the device and if it is not installed, there are two options, right? Either the Win32 application did not install to begin with, or the installation happened but the installation was not successful. But in both the cases, Intune management extension first needs to be there, right? Because it is the one which is our remote hands, which is doing the installation for us, right? So the very first thing that we will be checking is whether IME is there or not. And we check the IME logs, of course. How do we check it? Where do we check it? What do we check in that? It will all come later. But I hope that for now we know what is Intune management extension, where do we see it, why do we need it, and how it fits into the picture with Win32 application deployment or a PowerShell script deployment. Okay. All right. So this folder we have already seen that in under C drive program file, there is this Microsoft Intune management extension folder that gets installed. Okay. All right. So now we know there is a Win32 app. We know why we need it. Now we have a LOB application which needs to be deployed. The prerequisite is already made. The device is Azure AD joined or hybrid Azure AD joined, and we deployed that application. IME already got installed, right? But before I can deploy that Win32 application, how do I get the Win32 application, right? I mean, all I have right now is a package, or all I have right now is a .exe. I have the VLC media player .exe. How do I actually deploy it via Intune? So let's just take a look over a flow chart which talks about how this deployment is supposed to be done.
Okay, so this is a flowchart for the deployment, as in the steps or the checkpoints that we need to keep in mind before we end up deploying a Win32 app to a device. The very first thing that we need to keep in mind is, well, obviously the prerequisite needs to be met, right? No matter what kind of application we have, if the end devices are not meeting the prerequisite, it's not worth the trouble, right? Let's just make sure that the devices obviously are enrolled to Intune. The devices are Azure AD joined or hybrid Azure AD joined. We already discussed that. The operating system version should be 1607 or later. I'm assuming that is the case because this is quite an old version of Windows 10. And the application file that we are going to deploy must be up to 8 GB in size. So this is the current, I won't exactly say limitation, this is the current capping that we have from Intune, that the package that we are going to deploy, it should not be more than 8 GB. And I believe that 8 GB covers a lot of use cases, right? So I mean, almost all of the use cases should be met with this 8 GB capping. So this was the first thing, making sure that the prerequisites have been met. The second thing that we have to do is, well, obviously we'll gather the media and identify the application that we are going to deploy. So the file should be unencrypted, unzipped, and all we have to do is let's just get that file, put it in a folder, and let's just make sure that no other file is present inside of that folder other than the files which are relevant to this deployment. The reason why I'm saying this is because I once was working with a customer, and what he did was he kept all those files under C drive. And what happens is when we we will see this later, that when we are running the utility, what it does is it converts the all the files from the source path to .intune win extension, which is what we deploy from Intune. But if the source folder is C drive, then what it does is it in a way compresses the entire C drive. So you can imagine what is going to be the size of the Intune win folder in that case. So let's just make sure we are creating a folder, and inside that folder placing all the files, and there is no other folder, there is no other file or subfolder present inside that parent folder. And that parent folder is going to be our source path. Okay, and then comes the important part, which is identifying the install and the uninstall command. This is something that we are going to extensively do during our demonstration as well. Any application which is going to be, let's just say, which is a exe, or even if it is not a exe, even if it is a msi or any kind of application that we wish to package and deploy from Intune as a .intune win, then more often than not we have customers who come in, say that, you know what, we are trying to deploy this, but this is not really working out. I mean, it's failing. So the first question that we ask is, have you had a chance to install the same installer on a machine manually using the same commands which you are supplying via Intune, to see whether the application even supports a silent installation or not. So this is a very important step. Very usually you will see that the customers miss out on this one. We have to make sure that whenever we are installing the application, so from Intune, what we do is we deploy the application as a .intune win file, and we also provide the commands, the installation commands. So this is wherein we are telling the main tech guy that, you know what, this is the hard disk and this is the parameter. Similarly, we are telling the IME that this is the file that you need to install, and in order to install this file, these are the commands that you have to run. Now, if those commands, if running those commands installs the application manually, then the same thing is what we are expecting to happen via Intune as well. But if running those commands manually creates any, I mean, it gives any pop-up on the device which which the end user has to select or make any selection, then obviously when it's being done by Intune, then IME is not going to make that selection, right? So then the app deployment would fail. Okay, this is something that we need to keep in mind. And then downloading the conversion tool and packaging the app. So this is a process by which we convert a file which can be in .msi format or which can be in exe format to a .intune win format. So the conversion tool is packaging the app and is converting the app from a format which is .exe or .msi, .exe being inherently a format using which the application cannot be deployed via Intune, to a format which in this case is Intune Win, using which the deployment can be made via Intune. Okay, we will see all of this later. And then the last step during deployment is, well, obviously the prerequisite is met. We have the application, it is less than 8 GB in size, it has been converted into .intune win files, and obviously the last thing that needs to be done is we just need to upload this file into our Intune portal, specify the install and the uninstall commands and the detection logic and requirement and whatnot. And then we just need to deploy it and assign it to a user group or a device group. Okay, so this would actually be a flow chart of the deployment. All of these are supposed to be done by the admin. And there are some other considerations also that the admin might have to make while preparing the Win32 application, which we are going to see now. So this is a screenshot that I stole from docs.microsoft.com. So it actually tells us the process to create a .intune win file. And it's self-explanatory. First, we gather the media, then we identify the install and the uninstall command. So this is also something which we are going to discuss a little bit later on, that how to identify the install and the uninstall command of a .exe. And then once we have identified that, then we create the Intune win file. So we are using the tool. We have a tool, Intune win app utility, and that tool converts the .exe or .msi to .intune win. So once that conversion has been done, is it is the flowchart is saying that is it less than 8 GB? If that is the case, then specify the source folder and create the Intune win file, and then click. I mean, it's pretty straightforward. If before creating the Intune win file, if our package or if our existing exe is more than 8 GB, then what we need to do is we need to do any cleanup. We need to customize it or make some changes, whatever may be necessary, to make sure that our source or the setup file is less than, or the package is less than 8 GB. If it is less than 8 GB, then obviously we can again use the Intune WinApp utility at this stage and create the .intune win file. If it is still not less than 8 GB, then well, unfortunately, there is nothing that can be done. So, well, again, over here, it is just breaking it down to one more level. Okay. Cool. So now let's just talk about what the Intune WinApp utility tool is. This is a free tool available in GitHub, just a utility, converts the .msi or converts the .exe or some few other extensions. If it's a KB, we can convert that also, and it converts it to a .intune win file, which can be deployed as a Win32 application via Intune. So by using the Intune WinApp utility, we can convert an MSI, not just an MSI, we can convert other formats also to a .intune win file. We convert that and then we encrypt that file also. So the file that is deployed via Intune to the device, to the IME, is .intune win file, and that file is encrypted using a SHA-256 algorithm. So when we are, so the process is something like this. Again, we have this setup file. Let's just say this setup file was less than 8 GB. And if that is the case, then obviously only in that case our prerequisite will be met, and only then we can proceed. So what we will do is we will feed this file to a utility called Intune WinApp utility. Okay, Intune WinApp utility. And the output of this file, I mean the output of this process is that .intune win file. .intune win file, and this is what we are deploying from Intune. And it actually, if we take a closer look, we will see that when we are using the .intune, when we are using this utility, it actually creates a .intune win file, and we can actually crack open this .intune win file, and we will see that this .intune win file actually in turn contains two things. First is, well, obviously the setup file. So, well, obviously if over here we had a file called VLC media player, right? So that is what Intune win file converted into .intune win, right? So over here we will be having the setup file, which is obviously going to get installed in the end device. And we have another file, a XML file called detection.xml. Okay, we will actually do this in the demo. We will crack open a Intune win file and then we'll see what's inside. So this XML file actually contains all the information that is necessary to first decrypt this file and then install this file. Okay, so this is the entire process here. This is what the Intune WinApp utility is doing. As a part of creating the Intune win file, the encryption information is stored in the detection.xml, which is over here, which is a file which is created in the subfolder in the Intune win package folder named metadata. We will be all seeing this. But the process is very simple. We take the input, we parse it through a utility. The output of that utility is .intune win file. If we crack open that Intune win file, we can see the installer is there as well as an XML file is there which contains some configuration. One of those configuration is the information how to decrypt the package. Okay. Now we are going to talk about how to create a .intune win file. I'm going to very quickly run through this. This information is already available in docs.microsoft.com. Well, obviously the first step is we have to download the Intune WinApp utility, this utility. So this is something that we can, well, develop or we can download from store or whatever. This is something that we can get easily from GitHub. So it's there in our official documentation, and all we have to do is just click on download and the Intune WinApp utility can be downloaded from there. And then we have to copy all the installation files inside a source folder. So all these files have to be placed inside the source folder. Okay, and this will be created inside the destination folder. Okay, We just have to make sure, word of caution, that there is nothing else present inside the source folder. And don't keep it in the root directory, because then you will end up into a similar situation wherein it is wherein the Intune WinApp utility is actually compressing everything. It thinks that everything under C drive, if we have provided C drive as the source path, then it will think that everything under C drive is needed for installation. It will end up encrypting and compressing the entire C drive content, and then the Intune Win file will be very, very huge. Okay. All right. Keep the Intune Win file outside the installation source folder. Obviously, inside the installation source folder, we just need to put in the files that are needed for installation. So this is the setup that I have in my, if you would say, which I'll be using in the lab as well, on the demo as well. So inside C drive temp, I have created two folders. One is input, one is output. Output is empty. Input contains whatever file it needs to contain, which in this case input is containing, let's just say, vlc media player.exe. Okay, right now we have a exe, we don't have a .intune win file. And outside this input folder in the C drive temp inside Win32 folder, I have the Intune WinApp util.exe, which is a utility which I downloaded from the GitHub. Okay, now we need to execute the Intune WinApp utility. We need to provide the setup file name. We need to trigger the Intune WinApp utility. The output is .intune win file, which we already saw over here. This is the output. This is a compressed file, and this file contains in turn the XML as well as the setup, and it is encrypted using and it is an encrypted file using SHA-256 hash. Okay, so here is how we run it. So I have the input folder, I have the output folder, I have the Intune WinApp utility. So all I do is I go into C drive temp Win32, that is the location of this entire content, and then I run the Intune WinApp util.exe. So this is over here. I'm running the Intune WinApp util.exe. It is asking me for the source folder. The source folder is input. So I'm providing C drive temp Win32 input, and then it is asking me the name of the setup file. So inside this input folder, there is only one file that I have at this point of time, which is 7zip.msi. So I provided the name of the setup file as well, and then it's asking me the name of the output folder. So I provided this as the output folder. Again, self-explanatory. And then it just tells us, do you want to specify the catalog folder? We necessarily don't have to. And then it will do its trick. There is nothing that we have to do. And then it will complete successfully if everything was provided successfully. And then you can see that in the output folder, a 7zip.intune win file has been created. You can see that it is at 100%. And if we parse through this, we can actually see what is it that it is actually doing. It is first compressing the source folder, and it is compressing it and putting it in a different location under C drive users, my name, app data, local temp, and in this format, Intune package.intune win. And then it is calculating the size, it is compressing the folder, it's making a note of the time that it took, and then over here it has encrypting it, showing you the time that took to encrypt it. It encrypted it using SHA-256 hash, and what else is it doing? And then it is compressing the folder and then copying it from this location back to the output folder that I showed you. This would be a temporary location, if you would call it. And then the file is copied. The Intune win file, which is compressed and encrypted, is copied to the output folder. Okay, and then it tells us that it is removing the temporary file from this location. Okay. Cool. And once that is done, if we go inside the output folder, we can see that 7zip.intune win has been created, and we can actually crack open this file, this .intune win file, and see what is inside. Again, what is this file? We had a exe, so we had a 7zip exe. We passed it through a tool. In this case, the tool is Intune WinApp utility, and this is the output, right? What is the difference between the input and the output? The input was .msi or .exe. The output is .intune win. Okay, and we can, the point that I'm trying to make is we can actually crack open this file as well, the Intune Win file, and see what is inside of it, right? So we can see a normal zip, we can see what is inside of this file using by decompressing this. What we can see is if we decompress it, we can use tools like 7-zip. So I'll just show it to you. So what I did was I changed the extension of this file from 7-zip to .zip. Okay, and now I can use tools like 7-zip tool or the inbuilt compressor tool to open this file. So what I'm doing right now is the screenshot signifies that this file has been opened, and when I'm changing the extension and opening this file, I can see that there are two folders present inside. One is contents and the other is metadata. If I go inside the metadata, I can see that there is a detection.xml present inside. And if I open the detection.xml, I can see this is what the XML contains. It contains the name of the application for which this XML was generated, and then it contains the encryption keys. So this is the encryption key which the IME will be grabbing hold of in order to decrypt the package before it can start installing. And then it is containing the MSI product code as well and some other information. This is how it automatically populates in the portal when we upload it. Okay, and then it's containing other information as well, that when you install this application, whether it requires a reboot or not and whatnot. Okay, so so this is where we were compressing the source. So what is the processing that the tool is doing? The tool is compressing the source folder and files to a subfolder called contents, and which is having this extension of .intune will, and it is computing it with SHA-256 hash. It contains a metadata folder which contains detection.xml, and yeah, so, and it contains the setup file. Okay, so over here we had two folders. One is the content and one is the metadata. We saw what was inside metadata. If we go inside the contents, we can see the package inside of it. Okay, and as far as the commands that we have to run, well, these commands are pretty much straightforward, right? It actually tells us what is the source folder you need, what is the setup file, and the output folder. No other high level commands are needed per se. Okay, so over here, I mean, this is just I mean, if you just want to run it in one line without having those prompts, then you can do it in this way, right? You're providing the source and I mean the input location and the output location over here, and you're using the quiet command or the quiet switch, and the command generates a .intune win file. For MSI setup, the tool will retrieve the required information for Intune. We will see what this is talking about later on. Okay, there are a couple of switches also that you can use. We necessarily don't need it. I mean, the only one that we need is -S or -O, and this is just specifying the setup file and the output folder and the setup folder, right? You don't even need this. If you just run the WinApp utility, then it will by default ask you, because these are all mandatory parameters. Okay. Cool. So quickly moving through. So over here you see that there are two files. One is 7zip.intune win, which we converted, and the other is 7zip.msi, which we downloaded from the internet. If we do a comparison between the two, then not much difference. The one that is Intune win is obviously compressed and encrypted, therefore it is its size is smaller. It is 1.26 MB, and the 7zip.msi, which we downloaded from the internet, it's a little larger in size. It is 1.3 MB. Okay, not much difference. Looks also almost the same, but yeah, this is how it is. Okay. And I mean, yeah, we can do the same thing for any application. So I mean, I did the same thing for Chrome as well. So I mean, for the Chrome setup, what we did was we used the Intune Win app utility, and then we converted it into .intune win. Once we had the .intune win, what I did was I changed it to .zip so that it could be opened. When I opened it again, I saw that there was a folder called Intune Win package. If I double click and open it, I see that there are two folders inside of it. One is content and one is metadata. The content folder contains the content, that is the Intune package Intune Win. This is the setup file for Chrome, and the other folder, that is the metadata folder, contains the detection XML, which is going to contain the information on how to decrypt this package and how to install the stuff. Okay. All right, and now there is one more thing. I mean, there is a tool from Oliver Kieselbach wherein he's talking about how we can decode an encrypted .intune win file. I mean, the way this is useful is, let's just say that I am the admin and I have deployed the Chrome application, okay, as .intune win file. I uploaded it into my portal. I deployed it to the devices. The devices have that, and the devices have installed it, right? But I mean, now we don't have access to that Chrome Intune win file, right? Because let's just say that I had that Intune win file in my output folder. I went into the Intune portal, I uploaded it into the portal, and then I lost that file. I mean, I necessarily did not keep the file inside the output folder handy. So now that file is there with Intune, it's getting deployed to the devices as well, and it's getting installed. But what if tomorrow somebody wants to take a look over that file? How do we retrieve that .intune win file now? Because I mean, if it is a LOB application, let's just say we need to make some changes to the code of that application, or there is some action which that application is doing and we need to change some libraries within the application. How do we get, I mean, the question here is, how do we get that .intune win file once it has been deployed? There was a LOB application, the application has been deployed. Now we want that Intune win file again. Now we cannot go to the end machine and just get that setup file, right? Because that setup file is actually getting installed on the end device, but we need that setup file which actually got installed, right? So how do we get that? So there is a tool by Oliver Kieselbach wherein he has presented us with a script which tells us that how to take care of this. So we will do this during our demo as well. So all that needs to be done is, there is a Intune WinApp util decoder.exe which we need to install. Once we have installed that, there is a script that we need to run. Once we run this script, so this screenshot is taken from my Windows 10 machine, wherein two Win32 applications were deployed and installed. Okay, so all I did was I went to that device, ran the PowerShell terminal as an admin, and when I ran that PS1, it did whatever it needed to do. We will see what is it that it is doing. It is actually reaching out to the CDNs, and it is fetching all the information that it needs to fetch. And then over here you see that it is downloading the file for us, and the name of this file is tmp958c.temp. okay, so this is the one, and this is the other one, 81a6, right? So what it did was it downloaded two files for us. So if I change the extension of this file to .zip, and if I change the extension of this file to .zip again, I can actually see the content inside of that file. So I deployed two applications, one was Fiddler and one was 7-zip, and over here I can see that Fiddler and 7-zip are present. So the use of this is, I mean, how is this useful? The use case of this is, let's just say we have a LOB application, we deployed it, and the person who deployed it, he obviously he had the package, he uploaded it to Intune, but now he doesn't have the package, or now there is any other admin who wants to take a look over the package and that package is not handy, which can be the case, right? I mean, we usually should be keeping the package handy, but I mean, there can be instances wherein we have not. So this is how we can just track our steps back and we can get the setup files. Okay, there's a cool little tool that we have available. Okay, cool. Now let's just take a look over how we can deploy the application from Intune. So until now what we have done is we have made the determination, we have created the Intune Win file using this process. So we use this process and we created the Intune Win file, right? Now, obviously, that Intune Win file needs to be deployed to devices, and there are a few things that we need to keep in mind while we are deploying it. It is not as easy as just uploading it and then just deploying it to a security group. There are few other determinations that we have to make once the Intune Win file is ready for deployment. So, well, the way we do it is, well, we go to client apps, and then the way we deploy an application, we will select the same option. And in the drop down, we have an option which says that Win32 application. We are going to select that option. And then the very first thing that it is going to ask us is to select the the app package file. So we have to select the app package file. We have to upload it. We can browse it from any location and then we can upload it. So, well, I mean, yeah, the same thing. We have to go to apps, all apps, and then select an application. And then we have to select the option Win32 app. Okay, this is the screenshot from wherein we got it. Okay, from the portal. And then we just have to browse to that location and then we just have to upload that application. Okay, so over here you see that over here you see that we have uploaded the application, and now when we are uploading the application, you see it says that uploading the Intune package dot Intune Win. The extension over here is Intune Win, but over here it is saying that uploading Skype underscore exe, right? Because that's the name that is given, right? So I mean, all that needs to be done is we just need to browse to that package and we just need to upload it. Just need to make sure that the size is not more than 8 GB. Once that is done, then these are some few of these are mandatory. So we just need to enter the name, the description, the publisher, the category. So show this as a featured app in the company portal. So I mean, these are the information that you would be normally seeing when you're deploying any application, right? This is not exclusive to Win32 app. So that is what we need to. So we are done with app information. We selected an app package. We uploaded it from here. We just need to browse it, and then that's all needs to be done in the app information blade. Then well, yeah, over here we can, few of these parameters are mandatory, like the name, description, and publisher, and then we can select a logo and customize it a little. Okay, so over here you will be seeing there are many steps. Okay, so the first step was the app information, which we just provided. The second step is program, wherein we have to configure what are the commands that need to be run. So again, let's just do a rewind. I called Maintech. I told Maintech that, you know what, insert this hard disk, but then I have to tell him which hard disk, what is the specification of the hard disk, which hard disk he needs to remove, which hard disk he needs to insert, and all that, right? So similarly over here, I'm telling Intune management extension that install this application, but then I have to tell him, right, that what commands he needs to run to install it, in which context he needs to install it, how to identify whether the app was actually successfully installed or not. Once the app is installed, is there any reboot needed or not? All those information, right? So that is what we are providing under program. So over here, we are providing the install command and the uninstall command. Now I'll take a pause here and say that this install command and uninstall command need to be accurate, and we need to make sure that when we are running this install command and uninstall command, the application is getting installed silently, meaning there is no user intervention that is needed. So over here you are seeing that I have used a /q switch, right? So my suggestion would be take that package to one Windows 10 device and then install it using the same install command and uninstall it using the same uninstall command manually once to make sure that it works. Once that is the case, then use the install command and uninstall command in the portal. There is one tool that I'll also show you guys later on, which I mean helps us in determining the install and the uninstall command. Then we can select the install behavior, whether it needs to be installed in the system context or in the user context, and then we have to determine the device restart behavior, whether there is any specific action that needs to be taken, or whether the device needs to be restarted, whether it does not need to be restarted, and all that. Okay, so once an application is installed successfully, in almost all the cases, it exits with a return code 0. Okay, or in some cases it exits with the return code 1707. So this is what it gets populated with by default when we are configuring the application. That once the application got installed, IME is going to go to that thread and ask. And how will IME know whether the app installation was successful or not? It's not going to go to control panel and then see whether the application is visible over there or not, right? There has to be a better way to determine. So the way it determines is the Intune management extension sees whether the thread exited with a exit code with a return code 0 or 1707 or not. If it exited with a return code return code 0 or 1707, then it identifies that okay, the app installation was done successfully. Okay, we can add if we want as well, so it's not like we have to use this, but more often than not this works for us. And then over here it's saying that device restart behavior. This is the option. We can determine the device restart behavior on the basis of return codes. We can say that Intune will force a mandatory restart, or there should be no specific action taken. So I mean, if it is a Chrome or Mozilla or 7-zip or something like that, then there is no mandatory reboot that is needed, right? So this should suffice. And then we can specify the return codes as well. And then there are some return codes for soft boot, hard boot, and retry. Okay, we can mess with this. I'm not going to go into the very details of this now. We will probably try and mess with it a little during the demonstration. Okay, and then over here it's saying what is the device restart behavior. Again, the same thing, and then specify the device restart behavior after the app has successfully been installed. Select determine behavior based on the return codes to restart the device based on the return codes configuration, which we are setting up over here. And in the device restart behavior, these are the ones that we can choose. Determine behavior based on the return codes over here, or app no specific action, or Intune will force a mandatory restart, or app install may force a device restart. Okay, and then the next section that you see over here is requirements. So again, when we were just starting with this Nugget, we saw that requirement and dependency and detection logic is one of those advantages of using a Win32 application, right? And over here, I mean, this is how it makes a difference. So we are saying that there are a lot of requirements that we can probably put in, and if those requirements are met, only then the app installation, only then the app will be downloaded and installed. So there are various kinds of requirements that we can put in, like minimum operating system architecture, that the application, that the device should meet for the application processing to begin. The minimum operating system, the version of the operating system, let's say Windows 10 1903 or something like that. The minimum free disk space needed, the RAM needed, the minimum logical processors that's needed, the minimum CPU that is needed, and all that. And we have an option of configuring additional requirement as well, that install the Chrome application only if C drive temp folder is present. Okay, I'm just giving a very vague example, but what I'm trying to say is, there are a lot of customization that we can do as far as requirement is concerned, right? So over here, this is how and where we add the requirement rules, the operating system architecture, minimum operating system, and all those things. And then we have an option of configuring an additional requirement rule, wherein we can add a requirement rule by file, registry, or script. So we can say that, inside C drive temp, if a file is present called a.txt, only in that case, the Win32 application should be installed. If that file is not present, then obviously it should not be installed. So again, a very vague example, that file can be any file. Instead of file, we can just make use of a registry location, or we can use a script as well. So we can set up a script saying that, this script, if it ran, whatever requirement is present in the script, If that is met, only then the app installation and the downloading of the app should begin. Otherwise, the Win32 app should not be downloaded and installed. So that is also a requirement rule that we can put in. Okay. And so again, a requirement rule, if we're adding by file, we can add a path or a folder or a property over here. And then the next thing that you see over here is the detection rules. So detection rule is, I mean, as the name suggests, is how Intune management extension will know whether the app is installed already or not. If it is not already installed, then it will install it, and then again it will evaluate that detection rule and then see whether the installation was done successfully or not. Now it is equivalent to the main tech guy determining whether the hard disk had failed or not. How was he determining that? He was looking at the display and seeing whether there was an amber light, a red light, or a green light. If it is a green light, then he assumes or presumes that the hard disk is healthy. If it is an amber light, then it is warning. If it is a red light, then it has failed. So that is the detection logic that he's using, the color coding of the LED that blinks. Once he has replaced the hard disk, again he waits and looks for the same color coding in the LED. If again it is showing as a red, that means that the hard disk that was replaced was not done correctly. But if it shows green now, it means that the operation was successful. Similarly, IME is going to evaluate the detection logic first. If it is not met, then it will install the application and then evaluate the detection logic again. If it still fails, then it will tell Intune that the app was installed but could not be detected or something like that, right? So these detection rules, so what kind of detection rule can be set from the portal? There are a whole bunch of them. There are a lot of detection rules that we can set, and we will see a variety of them in the demonstration. So we can choose either we can choose to either manually configure the detection rule or use a script as well. So we have an option of using a script again. In the detection rules pane, we can add multiple rules, and it's going to be a and of all the rule. So if I mean I think I saw a DCR request on this once, wherein a customer was saying that, you know what, there should be an option to do an or. What it means is, let's just say there is a requirement. The detection rule says that inside C drive temp a folder should be present, which means that the application is installed, or a specific registry should be present, or a specific file should be present. This is not there right now. What we have is and. So if we have specified multiple detection rules, and if all of them are met, only then IME detects the app as successfully installed. And then we can manually configure the detection rules as well. With the MSI version, the product code, we will be seeing all of this. So over here, this is how it is showing from the portal. So over here, you see that in the detection rule, I have said that manually configure the detection rule, and the criteria that I have put in is there should be C drive temp folder created, and there should be a file called 7-zip, and file or folder exists. So if this file or folder exists already, then the app installation and download will not begin. So let's just say I have a device wherein C drive temp is not there. Then the Win32 application that whatever that I uploaded in the first tab will get downloaded, will get installed, and again it will see whether after the installation of that application, whether the C drive temp 7-zip file and folder got created or not. If it got created, well and good. If it still did not get created, even though the application did get installed successfully, well, the assumption is it's not going to create any file inside the temp folder. So in that case, we are going to see that the app was installed, but it could not be detected. So, well, I mean, C drive temp over here is a very vague example. The point that I'm trying to make is usually we will be using over here program files, and then program files or program files x86, and then the install location, so that a specific excuse me, we'll be using that specific folder over here, which gets created after the app gets installed. Okay. All right. So again, it's just an explanation. We can put in a file, we can put in a path, or we can put in a file or a folder, or we can use a custom script. All right. So, and then we have something called the install context as well. I think we already spoke about this. We have two install context, system and user. And then user context refers to a given user only. System context refers to all the users using a Windows 10 device, right? End users are not required to be logged in onto a device to install the Win32 application. The Win32 app install and uninstall command will be executed under admin privilege by default when the app is set to install in user context and the end user on the device has admin privileges. Okay, so this is how it looks like. So I just uploaded an application over here and I call it firefox.exe. I mean, I'm calling it firefox.exe, but the application that I uploaded over here was not a exe, it was a .intune win file. So from here you can actually see the timeline that the app was created at this time, and then the app was uploaded to the portal, and then the app was assigned to a group, and at the end device, the device over here, we can see at what time the app was installed, and after the app was installed, whether there was any check-in that happened or not. Okay, so it gives us the entire timeline of what happened in this device at what time with respect to this application. You just need to open the device and then go to manage tabs, and then we'll be able to see all this. In case it fails, we have an option of collecting logs from the portal itself. So I mean, yeah, and this is really cool, right? I mean, I have not seen any other instances wherein we had this option. So we cannot collect the MDM diag logs or the event viewer logs of a Windows 10 machine from the portal, right? We are usually dependent on the user to provide us that information. But for Win32 application, if it fails, then from the portal itself, we can initiate a session which will download that file, that Intune management extent, the IME log file. So the IME is our remote hand, right? So everything that IME is doing is logged in a log file called Intune management extension log. So we have so if anything fails, we have an option of downloading the log file from the portal itself for this specific device. So we have to tell the portal that from where this that file needs to be fetched. We'll see all of that later. Okay, cool. Again, a disclaimer. This is something that is very, very important. For Intune to be able to deploy a MSI package, the MSI or that exe needs to be, I mean, it must be able to be installed silently. Okay, if whatever switches we are using, if those switches are not able to install the application silently, and if it's giving us any pop-up messages or any selection that the end user needs to make, then obviously it's going to fail if we are deploying it via Intune, right? Because there is nobody, because the end user is not going to do that. We cannot rely on the end user to make that selection, right? And if the MSI package requires any user interaction, the deployment will fail. It can be difficult to tell which package supports a truly silent install. So it's always a good idea to test this manually before deploying the package. Test it manually on a device. Make sure the parameters and the switches that you're using is working fine seamlessly on the device. If that is the case, then the expectation is from Intune also it should work. Now let's just talk about delivery of the Intune Win file to the client. So first we are going to take a high level overview of how exactly a Win32 application is deployed to the device. So the very first thing, obviously we have already seen this. This is a kind of repetitive, so I'll quickly walk through this. The Intune Win file is created and uploaded into the app section. So we upload the Intune Win file after obviously converting a .exe or .msi to a .intune win using the tool that we have. So what Intune does is it decompresses the package. We have already seen this. It creates the content as well as it creates another file called detection.xml, and it deploys. Now at the end device, the remote hand is already there. That is, Intune management extension is already there, and the request from the end device will come for the app download, and the download URL that is pointing to the .intune win file is presented to the device. The detection XML is also delivered to the device because the detection XML is needed to decrypt the package. The device reaches out to the CDN or the URL, fetches the application first it sees whether the requirements are met or not. If the requirements are met and if the detection logic is evaluated, after that the application is downloaded, it is installed, and then the processing takes place. So we will break this down more in I mean very shortly, but this is a high level block diagram of how exactly the application, I mean the phases through which an application is going through before it can be delivered to a device or before it reaches to the device, right? So the Intune Win app package file gets uploaded into the Azure storage account of the tenant. So that's equivalent to, I mean, this is the same thing if we were to upload a .apk or IPA. And then Intune decompresses the package, retrieves the detection XML from the metadata folder. We have already seen this. And when a request for the app comes in case of available deployment, so in case of available deployment, the user opens up the company portal application or goes to the website for company portal application, clicks on that app icon. That's when the request is generated from the device end, right? If it's required, then I mean it goes by default. There is no user interaction or intervention needed. So when a request comes for the app download in case of available deployment, or if it is deployed as required, the download URL to the encrypted .intune win file is delivered to the end device. The IME the agent, which in this case is IME, it gets hold of those URLs, it downloads the file, downloads the policies, and then takes it up from there. Okay. Intune also sends the decryption information to the IME for the client to decrypt and unzip the content. After the agent gets installed, when I'm saying agent, I'm referring to the IME. It will start to figure out the service endpoints via service discovery. It reaches out to the CDN. After getting the Intune service URL, the agent starts to communicate and receives the assigned policies. We will again see all these flow and all these stages when we are taking a look over the logs. Okay. Cool. Now let's just see the processing at the device, and again we are going to look at a similar block diagram, but this is like we are breaking it down even further. So this is a block diagram. I have filed for a blog on this. I'm not exactly sure whether it's available in tech community yet or not, but yeah, I mean this is the exact breakup of all the stages that is happening right from when the app is about to be downloaded until whether the app succeeds or whether the app fails. Okay, so let's just understand all of these step by step. There are around 1 2 3 4 5 6 7 8 9 10 11. There are 11 steps to this. Well, obviously the first thing that happens is that a Win32 app is deployed to a device. Well, obviously the prerequisites, the steps that I haven't mentioned over here is the admin steps, wherein the admin is creating the Win32 app and using the tool and is deploying it and is creating the policy. We have already seen how that happens, right? So let's just say all that admin tasks have been done and the Win32 app is deployed to the device. Obviously, the first thing that would happen is that Intune management extension will get installed and the IME polls every 60 minutes. Okay, so the app is deployed to the user, IME gets installed on the device. Once IME is installed, the IME initializes and it runs a couple of checks. So IME is going to check whether the device in which it is running, whether it is running in S mode or not, and it will log it. And then the content manager handle will start in the IME and it will make a note of the device ID and the OS version. All of these will be logged in the IME logs, which we will see later. Then IME is going to impersonate the user and it is going to fetch the tokens, the token it is going to need in order to authenticate and in order to download the policies that it needs to download. And then once all that has been done, IME is going to reach out to the CDN and it's going to get a list of the policies that have been targeted to this user or to this device. So we can actually check the IME log, and if we check with the keyword get policies, we can see that IME is trying to get all the policies that have been delivered to that user or to that device. We can see the policy XML. I mean, we can see the policy that is coming down, and the policy that we see coming down to the device is obviously in accordance with the policy that was created in the portal. So we see, we as an end user can see all the settings that was configured by the admin in the portal just by looking at the logs, right? We will do all of this. And once the policy comes down, the first thing that it does is it checks if the discovered app is dependent on any other application as per the policy or not. So it's going to check the dependencies. Like for example, let's just say that the policy that I created was for deployment of VLC media player, but in the VLC media player I made a dependency on Skype. So first it's going to check whether there are any dependencies there or not, whether the VLC media player application is dependent on any other application or not. And whatever, if it is dependent on any other application, like in this case VLC media player is dependent on Skype, then it is going to make use of the detection rule and see whether Skype is already installed or not. If it is not installed, then well, the processing will happen. If it is already installed, then the detection rule will say that okay, Skype is already installed, we can go ahead with the installation of VLC media player. So over here IME is checking if the discovered apps, whatever the discovered apps were there, I mean I could have deployed just VLC media player or could have deployed 10 applications, right? So if I deploy 10 applications, then get policies will show the name of all, name and the app ID for all those 10 applications, as well as all the relevant things that we configured at the portal. So IME now will check if the discovered apps is already installed in the device as per the detection logic. And if it is already installed, well and good. Let's assume it's not installed. In that case, detection logic fails, as in the detection logic is not met, meaning the application is not installed. Therefore the next process will come wherein it will check the applicability and the requirement rules that has been set by the admin, wherein we are setting that, you know what, the app should only be installed on a Windows 10 1903 machine, and if there is 100 MB of free space in the C drive. So the IME will check if the app requirement policies are met. If that is the case, then IME will start the app package download, and the app package is first moved into the incoming folder. We can, so everything that I'm saying over here, every sequence is logged in the logs. We'll take a look over the logs, we will establish all of these, but I mean, yeah, just a block diagram on how exactly the phasing, the phases are there. So IME will start the app download. The app package will be saved in the incoming folder. We can see the size of the package that has been downloaded, the time that took to download that file, and all that. Once it is moved, once it is downloaded from the incoming folder, it will be moved to the staging folder, and IME will run a couple of checks and make sure that the app, that the package that it downloaded is still encrypted and signed. If that is the case, then it will decrypt that package using the information in the detection.xml file that was also supplied to the device, and then it will decrypt it and moved it to the staged folder. And now we have the app, all the prerequisites have been met. So now the app installation will start. So in the policy itself, in the get policy itself, the entire policy body came down, which also contained the installation command. So IME will now set up a timer and it will start the installation. It will set the installation directory. It will run those install commands. It will make sure that the installation goes fine, and it will keep on, and IME will keep on monitoring the exit code of this process, of this installation process. So once the installation finishes, it's going to see what is the exit code. If the exit code matches with the exit code that we set in the policy, which usually is 0 or 1774 or something like that, 1717, we already saw this, right? So let me just go back. I have already shown this, so I won't go back again. So IME is just going to match the exit code. If the exit code is 0 or any exit code that we defined in the policy as successful, then IME will say that okay, the app installation was the app installation happened, and IME will mark it as a successful installation. Then IME will close the handle and it will stop the timer, and in the logs we can see that the handle is closed, the timer is stopped, and we can actually see how long it took for IME to install that application. So installation happens, and then IME will check the device restart behavior. So when we were making the policy over there, we had an option which says that what is going to be the device restart behavior after the application is installed successfully. So over there, if we have mentioned reboot, then the device is going to undergo a reboot. If not, then it will skip it. And then the detection logic, the detection rule that was evaluated here will be evaluated again
right? And it only makes sense, right? I mean, we detected the detection rule. I mean, we evaluated the detection rule before the app was installed. Now the app is installed, we need to evaluate the detection rule again, right? Only then we will be sure whether the installation happened or not. Just like we first saw whether it was amber light or red light or green light in the LED when the hard disk had failed, right? When we change when the main tech guy changed the hard disk, again he is going to see whether it's showing green or not, right? Only then. Just replacing the hard disk doesn't mean that the replacement was successful, right? He has to see whether it is still showing green light or not. Similarly, over here, just installing the application doesn't mean that installation was successful, right? It needs to check the detection rule or the detection logic again, the same detection logic for that same application. So IME will detect if the app was installed successfully or not by evaluating the detection logic again. If the detection logic is met this time, then IME will assume that okay, the installation happened fine, and then it will send the status of the app installation to the Intune service, and then it will display a toast message at the end user's device also saying that the app installation was successful. If this fails, then well, obviously we will see later on that what is it that we find in the log. But this is again a breakdown of the different steps that take place during a deployment, installation, and processing of a Win32 application in stages. Now we will take a look over, now we will correlate this and substantiate this with the logs, and I will show you that what we see in the logs is in accordance with what we understood here in the block diagram, and it happens in the same steps. So I just did not come up with these steps as per my liking. The steps in the log collaborate the same thing. So this is now just, I mean, over here, this is not the actual log. We will see the log later on, but this is just showing the same thing that we saw in the block diagram. So I'll just very quickly go through it. The Intune management, so this is the flow that happens in sequence. The IME gets installed. Sorry, the IME gets initialized, the EMS agent gets started, S mode is checked, content manager starts, and then it makes a note of the device ID and the OS, and then it discovers the endpoint of Intune, the Intune URL, the service URL if you would call it, and then it impersonates the user and requests for token. Once the token is granted, it sends a put request, and we see a get policy response from the Intune service, and the get policy response it signifies the entire policy body that the Intune management extension downloaded from the Intune service, which contains everything that the admin configured at the Intune level. So in the get policy, we can see the entire policy body, we can parse it, we can understand everything that has been configured in the policy. Now the exec manager will identify the name of the application, the app ID, and the app installation intent. We can see the app ID over here, which should match with the application ID, which we can see from the portal. And the first thing it will check is the dependency, and it will discover all the applications. Like for example, just like I said, if we have only deployed VLC media player, but VLC media player is dependent on 2 other applications, then all those 3 applications in total have to be installed, right? So IME is going to discover all those 3 applications. It's going to evaluate the detection rule for each of those applications. Once the detection rule is evaluated, it will see, okay, if the app is already detected, then nothing needs to be done. So once all that is done, the applicability check and detection rule, all that is evaluated, then the end user gets a toast notification in his Windows 10 machine. On the right hand side, he will see a notification saying that the download is starting, and in the logs we will see that the download timer is set, and then the content is downloaded to the incoming folder. We can see the ID. This is the app ID, and then when the download is done, the download job completes, we can see the bytes that was downloaded, and then that file that was downloaded, it gets the package's identity is identified, and then it is decrypted. After decrypted, it is moved to another folder called IME cache, and then the staging content, that is the content that was there in this folder, is deleted, and then now the content has been downloaded. Since we have everything in place now it's time to install. Therefore now the installation will start, and then it will grab hold of the command that we put in the policy, which is going to be the installer command. So that is going to be evaluated over here. Installation starts. Once the installation finishes, IME keeps a check on the exit code, and if the exit code is 0, then it determines a success. Then the device restart behavior will be checked, and then the detection rule will be, the detection manager is going to detect the application again. So it's again going to check the detection, whatever detection we have put in. And once that is done, depending upon what the outcome of the detection logic is, if the same detection logic is now able to evaluate, okay, the application was installed successfully, then it will send that message to the Intune service, and all the interim folders that were created and the files that were stored will be deleted from there, and Intune service will be notified of that. So as far as the log location is concerned, I'll very quickly go through this. So we have already spoken that this is the location, C drive, program data, Microsoft, Intune management extension, and logs. These are all the log files: Intune management extension log. And then we have agent executor and client health log. Agent executor is usually used for tracking PowerShell deployment, PowerShell script deployment. Intune management extension is used for Win32 app deployment. Client health log is used to, it's used for making sure that the IME agent, that is the main tech guy that we have over there, he's keeping well. That's what the client health log is for. So now we have taken a look over the flow, and this flow is in accordance with what we saw in this block diagram. Now we will take a look over an actual log. So and before we do that, this is the same information but in steps. So you can just read through it. It's more or less the same information in 32 steps, I guess. So it does the same thing. We will see all of this happening in the log extract. So I have captured the logs, and this is unedited log, just copy paste from the log file, and you can see that the same thing is happening over here, right? EMS agent is starting, and it's making a note of the content manager is making a note of the device ID and the OS version, and then it's starting the impersonation for the account, and then token manager is getting the token so that the user can be authenticated. Once that is done, it sends a network request, and it gets and this is the get policy response. So it just did a get policy, and over here it received the policy from the Intune service, and this actually contains the entire policy body. So over here you can see that this is the name of the application that we defined in the portal, EI-7zip, and the detection rule that we put in, and everything that was there in the policy is coming down to the device. You can say that it is coming down in form of a XML, if you would call it. So over here you can see that require minimum free disk space is 100, because I put it to 100 MB, and then system OS architecture, it's saying 3, so I'm guessing that 3 is signifying some value, and then minimum memory in MB, I put it to 100 MB in the portal, in the policy, maximum retry counts, and then all the codes that I defined is coming up over here as well, the return codes, and there were some dependencies as well, which it is showing up over here. And so if we parse through this, we are going to see that all the information over here, you can see that there is a dependency for TeamViewer as well. TeamViewer application is also dependent on this, and whatever the return codes are there for each application is showing up over here. So this is a XML file, if you would call it, which is containing all the information, and it is in accordance with what was set up in the policy. So, and then it will tell us that, you know what, we got one Win32 application. If there were 3 or 4 exclusive Win32 applications, then it will tell us that we discovered 3 applications. Each 3 will have a different policy body, and then the exec manager is telling us that we are going to process this application. If there were any dependency, then it's going to tell us about the dependency as well. It's the it's first going to, the detection logic is going to run, and then it's going to tell us whether the app, first it's going to check the dependencies. So in our case, this was a standalone application and there was no other dependency set. So over here it's saying that the dependency is set to false. If that is the case, then the detection logic will start. So the detection manager is starting, and over here it is checking. So in my so the detection logic that I used was whether inside C drive temp, whether there was a file and a folder called 7-zip created or not. So over here it's checking that the path does not exist. Obviously before 7-zip is installed and after 7-zip is installed, in both the cases there is no file created inside C drive temp, right? But this is just a playing that I was doing. So over here it says that the path does not exist, the detection logic was fail. And if that is the case, then the sidecar detection manager returns false value, and then it checks the application. So I mean, if what I'm saying is the app was not detected, right? If the app was not detected, it means that the app is not present. Therefore, now the processing will continue. It's going to check the requirement rules and all that, and then it's going to download the application and try to install it. So the next thing that we see is it's checking for the applicability, whatever we have set in the C drive. Over here you can see it's checking whether 100 MB of free space is there or not, and whether the specific amount of RAM is there or not. And then we see there is a toast message that comes for the user which says that the download is starting, and over here you can see that the download starts for this application. This is the app ID, the download is starting, it's creating a download job over here. And the next thing we see is in the incoming folder we see a file over here, and this is the file. This was the job ID, the job was started, the job is finished, and then it will tell us how much of time it took, what was the duration, how much of file was downloaded, what was the size of the file. And then once that is done, the file is downloaded, it will verify the encrypted hash, and then it will decrypt it, the download size, the download file size, and then it is starting to unzip the file. And then once it is unzipped, it is moving it to this, it's moving it from this location to this location, and then the content in the old location is removed. Then it is going to parse the install exe, and now the file has been downloaded and decrypted, right? So now the next thing that needs to happen is installation of the application. So now over here you will see that the install behavior is going to start, and it's going to use the same command which we put in the portal, and this is that command. Once the installation happens, there is going to be a timer that gets started by the IME as well. Once the installation finishes, IME is going to collect the result, and it's going to make a note of the IP exit code that the application gave. Once that was done, IP exit code, depending upon the value of the IP exit code, we are going to see whether it was a success or a failure. Then it's going to evaluate the restart behavior, and the handle will be closed. The installation is done. Now again, Maintech needs to identify whether it's an amber light or a green light, meaning whether the app can be detected now or not. So in this case, well, even though the app was even if the app was installed, still inside C drive temp no folder of named 7-zip is going to be created, right? Because what I'm trying to say is, in this case the detection logic that I'm using is incorrect. Instead of this path, if I referred to C drive program files and then 7-zip or something like that, and if that file gets created, if that folder gets created after 7-zip is installed, then probably over here we would have seen that application detected as true after the app was installed. But in my case, I'm using an incorrect detection logic, therefore it still says that the detection was false. Therefore it sends a message and to the Intune service saying that the installation was successful, but it failed according to the detection logic. Therefore we are going to get a toast message in the device which says that the installation was unsuccessful, right? Because the C drive temp 7-zip folder was not detected by the application by the IME after the application got installed. If I use the correct detection logic, then obviously it would have identified the correct folder, and then we would have got a toast message saying that the installation was successful. Okay, once that is done, the result is sent to the Intune service, and all the other interim data is deleted. Right, so the logs that we see over here are in sequence. I mean, it would have made a little bit more sense if I had the timestamp as well, but please believe me when I say this, these logs are in sequence. I have not messed or meddled with the sequence of these logs. I've just removed the unwanted content, but these sequence of logs is what we would be seeing in the demo as well. And you will see that this correlates with the block diagram that we had established over here, right? So whatever we saw in the logs is in accordance with what we saw over here, right? All right. So this is what we see if there was I mean, if the app got installed and downloaded and everything happened fine. If there was any dependency, then there is just one thing that changes in the log itself. We will be able to see that it the detection rule finds out that there was a dependency. So we see a line like this, that it says that Skype dependency 1 of 1 is being downloaded as a part of EAI 7-zip installation. So what I did was, first I deployed a 7-zip application as a standalone. Then what I did was I uninstalled the application, and then I deployed 7-zip again. And in the second case, what I did was I made a dependency of 7-zip on Skype, which means that if Skype is not present in the device, then Skype would be installed first and then 7-zip will be installed. So in this case, what we see is there is another line that comes up in the logs wherein the IME identifies that Skype dependency has been identified. It is dependency 1 of 1. If there are 5 other dependencies, then it will process each of those dependent apps, like 1 of 5, 2 of 5, 3 of 5, and so on and so forth. And then Skype app gets decrypted, unzipped, installed. Its IP exit code is governed, and if Skype app is identified as successfully installed, then after the detection logic runs again, then the detection manager starts to download and work on the 7-zip application, because obviously 7-zip is dependent on Skype, which means that the processing for 7-zip will not start unless and until Skype has been downloaded, installed, and our detection manager tells us that okay, Skype is present in this device as per our detection logic. Okay, so all right. And as far as retry counts are concerned, we have a maximum of 3 retry counts, and the interval between each retry is 5 minutes. The maximum execution runtime is 60 minutes. What it means is if we are installing any application, if it took more than 60 minutes, then it's going to time out. So it's a default timing that we have as of now. I'm not exactly sure if this is going to change in any time future. Okay, now let's just talk about the registry location. That let's just say the app got installed. What are we expecting to see in registry and where? Right, so the registry for this for IME and Win32 app deployment is HKLM software Microsoft Intune management extension. That is the node here, and inside Intune management extension you will be able to see a node, and this is the app ID ending with 5C. And over here we see a bunch of information. The other node is, there is another node called Win32 apps. When we go inside Win32 app, again there is a node which gets created with the same app ID. Over here you can see ending with 5C. Over here also you can see ending with 5C. This is the app ID. It gets created inside the user IDs node. So inside Win32 application you will be seeing that there is a node for the user ID and then the app ID. And over here we can see all the information that is that the registry got updated with once the policy came down, as in what is the intent, whether it is available, whether it is required, when the device got rebooted, what else is happening or is going on with respect to the policy. The other node we have already spoken about is the Intune management extension node in the registry itself, this one. And we will, in the demonstration, we will actually take a look over what this node contained before the app installation, after the app installation, and during an incorrect app installation. So we will cover all of this. Now let's just take a look over how and what we see at the end. How do we verify whether the app was successfully installed or not, or which logs to check? Well, obviously one log is the IME log, right? Where else will I be seeing logs or traces of logs during a successful or unsuccessful installation of an application? So let's just say that I deployed chrome.exe. I converted it to into Intune Win file. I deployed it. Obviously it will be populated in the registry. It will be there in the MDM tag logs. It will be there in the IME logs. Along with that, once the application is successfully installed, or once the application is going to start to it's going to start the installation, we'll be able to see the application logs as well under Windows logs. So over here you can see that with the source MSI installer, I see that it's beginning the installation of this application, this is the app ID ending with 5C and then 7zip.msi. Once the installation is done, in the same application logs, we can see an ID which says that the product installation was done successful. Well, obviously under Windows log application, we see everything that is going on with respect to applications, right? So we are installing a Win32 application. It's fine that it's recorded in the IME log. Well, it has to be recorded in the event log as well, right? So this is where it is in the event log. And this is the toast notification that I was talking about. So the toast notification comes in the Windows 10 device. First, it gets a toast notification saying that your IT administrator requires to make changes, and then the download and the installation starts. If you remember the first scenario that I spoke about, we were installing the 7-zip application, but the detection logic that we were using was incorrect. So the detection logic that we were using was inside C drive temp, there should be a folder called 7-zip created, which obviously is not going to get created. So the app got downloaded, the app got installed, and after installation, the detection manager ran the detection logic again. And since it still was not able to detect the application, this is what it says, that EAI 7-zip installation failed. Even though the installation happened successfully, the detection logic was not met. Therefore, IME thinks that the app installation did not get completed. Or if I use the correct detection logic, then you will be able to see that the application was installed successfully. Okay, and we have already taken a look over the registry locations, and this is what we see in the portal. So in the again, coming back to our first scenario wherein the app was installed but the detection logic was incorrect, this is what we see. It says that the application was not detected after installation completed successfully, because the detection logic was not met, right? And if the app was already present, then it tells us that the app is already installed. All right, so now.
So guys, this is another use case that we have. So I just wanted to present one more use case. In this case also, more or less it was the same thing. So what I did was I deployed the 7-zip application to a device. Device was already joined and all the prerequisites were met. And the detection logic again for 7-zip application was the same. That is, there should be a folder called temp created, and inside in the C drive, and inside temp this file should be present in that location. Now what I did was I took a fresh machine and I created this file and folder structure in that device. Okay, so what I did was again a fresh machine. The machine is already joined, enrolled to Intune. I created C drive temp folder structure, and in temp I copy pasted the 7zip.intune win file. Okay, then I deployed the Win32 application, and the detection logic was this. So now let's see what happens. So over here we see that we will be able to see get policies, meaning the policy is coming down, everything remains the same. And then over here you see that the detection manager is starting, and then it is using the same detection logic which says that check the file path this, and application detected is true. What I'm trying to suggest here is, even though the 7-zip application is not installed in the device, still the IME thinks that 7-zip is installed, and that is because it is not going into program files and then it's not going to appwiz.cpl from control panel and checking over there. It is just blindly trusting this logic. And since I had already pre-created this temp folder and I had placed this file, the setup was not installed, only this file was placed. IME thought that the application is already installed, therefore the app installation did not happen. Okay, so the point that I'm trying to make here is I just wanted to stress on the fact that how important it becomes that we make sure that our detection logic is correct, because if our detection logic is not correct, we might run into such scenarios wherein the app installation even might not begin. Okay, all right, so now again I just wanted to spend some time in discussing this topic which talks about how to push a specific KB. Now this was important because we did not have this ability earlier. So if we remove Win32 app from the picture, then from Intune we cannot push a specific KB down to the devices. We can manage patches of Windows devices, however that is using Windows update train, and in that we can only customize how the device is going to behave and when the patching is going to happen. But what patches are going to be installed, that is something that we cannot govern. Now this brings us to a very valid point, that let's just say that there is a patch. We know that this patch is must for all the devices. What is it that we can do from Intune so that only that specific patch gets pushed to the device? Now we know that if you have heard, if you have used any other patching tool like Lumention or Ivanti or Shavlike, or even if you have used SECM, so in that case we know that we have the ability of pushing a specific KB down to the device. And now with the help of Win32 application deployment, we can achieve the same via Intune as well. The way we do it is, let's just say that I downloaded a specific KB or a specific patch. So the extension is .msuis. So I had a specific patch, I just downloaded it from the internet, and all I did was I used the same utility and converted the file to a .intune win file. Everything was fine, and this is what the end result was. So the detection logic ran first. Obviously, what I have not shown over here in the log is, well, obviously the get policies would have happened and the policies would have come down and it would have seen the requirements and dependencies and all that. Once that would have happened, then the what I did was, in this case during this deployment, I used a PowerShell script for the detection logic. I'll show you guys what that PowerShell script was. Okay, so this was the PowerShell script over here. So you can see that the detection manager is starting over here, and the detection manager is running, and the detection manager is running the PowerShell script, and over here you see that the PowerShell script is exiting with a IP exit code 0 and a PowerShell exit code 1. So this PowerShell exit code 1 signifies that the output of what the PowerShell was looking for. This is what the PowerShell was looking for. So this is the script that I used in my detection logic. So what I'm saying is, go to systeminfo.exe. So if you run systeminfo.exe, you can find out all the KBs that are installed in the device. And then once you go into systeminfo.exe, find whether this KB ending with 65 is there in that list or not. So this is what my KB is, ending with 65. If you are able to find it, then, well, the write output is not really needed because nobody is having a PowerShell terminal in front of him to see what is written. But I want to exit with exit 0. If you're not able to find this, then I want you to exit with exit 1. So when this runs for the very first time, then obviously this KB is not installed, and if that is the case, then this if condition is false and this condition is true. And if this condition is true, then the PowerShell exit code is 1. If PowerShell exit code is 1, then later on, which means that it is true, which means that the detection logic is true. When I'm saying detection logic is true, what I mean is that we were not able to fulfill the first condition. We were able to fulfill the second condition, the else condition. And in that case, we see that it says that application detected by current rule is false, meaning that the KB was not detected. And then we see that the KB gets downloaded, installed, the very same thing happens. And once all that is done, then obviously, as we already know, and we have already seen in the block diagram, the detection logic runs again. So over here, we are seeing that the detection manager is running that PowerShell script again. And when it is running it for the second time, we see that the IP exit code is 0. And now the PowerShell exit code is also 0. What I mean by that is, in the second case, this condition was true. Therefore, it was exiting with exit code 0 because it was able to find this KB because this KB was obviously installed. So in this case, the exit was 0, and since it was 0, now it is saying that the application detected is true. We will do a demo of this as well to show you guys how it actually works. But what I'm trying to tell you guys is, if you want to push a specific KB down to the device via Intune, now it is possible. This is how you do it. This is how you convert it. This is what we are expecting to see in our Intune management extension logs. And this is this is how our detection logic might look like. Now, instead of using this detection logic, instead of getting this information from system info, you might have gone with another route. You might have found out what registry changes that KB actually makes, and then probably you would have tried to detect it using that. That is also a viable option. I mean, this is the route that I wanted to take because this was the easiest one available for me. And then probably this logic should be applicable for any KB that we are trying to download and install. We will take a look over a couple of them during our demonstration. So this is what the end user experience is. So first we see a toast notification saying that your IT department requires you to make any changes, and then we can see that the KB is getting downloaded, and then we see a toast notification saying that recently installed. It requires you to restart the computer and whatever if a restart is needed, and yeah, so the detection logic was passed. So my detection logic was correct, obviously. Okay, so well, again, this brings us to the point that using PowerShell for how can we use PowerShell for detection logic? That is what we are using over here itself, right? For deploying a KB, we use this PowerShell script for detection logic. When there was a exit 0, then we were able to see exit 0 for then we were able to see exit 0 for PowerShell. When it was exit 1, it means that the if condition was not met, and that is what we used over here. Right. So again, this is very useful because it gives, I mean, if it's opening the door of PowerShell for us, then I mean, it's up to us that what is the level of scripting we actually want to do, right? And then, I mean, sky would be the limit, right? So again, so let's just take a look over how we can use PowerShell for detection logic. Now this time I'm going to, show you guys the screenshots from the IME log itself. So over here you see that the more or less the same thing is happening. The policy is coming down and all that. So I'm going to skip all of that. And then over here you can see that we were using firefox.exe, and I was using a detection logic for Firefox, and the detection logic was not whether the folder under C drive program files x86, whether Mozilla Firefox folder is present or not. Instead of that, we were using in the detection logic, we were using a PowerShell script. So over here you can see the detection manager starts, and the detection manager runs the .ps1, and a process ID is created, and then we see a exit code 1, and then we see that the application was not detected. Since the application was not detected, then it is going to download and install the application, and then it will run that PowerShell script again, because the detection manager will run it again, and that time the PowerShell exit code should be different, and then it should report as successfully installed. Alright, so we will take a look over all of these in detail during our demonstration. Now the other thing that I want to talk about is dependencies. So we have spoken about the dependencies a little, but I want to explore it a little bit more. It is again self-explanatory. What it means is if there is an application A, and I want that the application A should be dependent on application B. What that means is that A should only be installed if B is installed. And if B is not already installed, then B should be installed first. And only after B is installed, the installation of A should begin. That is what dependency is, that A is dependent on B. Okay, and there are many circumstances wherein we might need that, specifically for a package. So this is how we set up the dependencies. So over here, what I'm doing is I am deploying the 7-zip application. Okay, so everything remains the same. The install command, the uninstall command, everything remains the same. I can set up a requirement. All of that remains the same. The detection logic can also remain the same. Over here, I'm using a very default manual detection logic, which is saying that the file under C drive program, C drive program files x86 should contain a folder called 7-zip. Right, which means that, well, first time obviously it's not going to be present. Once the application is installed, this folder gets created automatically. But over here, the section that you see which says dependency, this is wherein I'm going to do a little fiddling. And over here, what I have done is I have created 3 dependencies: one for Skype, one for Chrome, and one for Firefox. So what this means is that the 7-zip will only be downloaded and installed in a device if Skype, Firefox, and Chrome, all of these are already present and detected. If these are not already present and not already detected, then the installation for these applications will have to be triggered. Please note at this point of time, I have Chrome, Firefox and Skype, I have not assigned these applications from the portal. They are created. So just like when I'm going into Microsoft Intune client apps, over there I have deployed the 7-zip application, right? And then I have assigned this deployment to a group. Similarly, Skype, Firefox and Chrome are set up, but they are not deployed to any group. So what we will see is, even though these applications are not deployed to any group, since there is a dependency, these applications will be downloaded and installed automatically, and once they are detected as successful, only then the processing for this application will start. So over here you see the screenshots from the end device. So the first prompt that comes up, it says that 3 of 3. So there were 3 dependencies, right? Chrome, Firefox, Skype, or if there was a fiddler or something like that. So if there is dependency, then you will see that 1 of 3 dependency detected, 2 of 3, 3 of 3, and then all those dependencies will first be downloaded and installed. Once the dependency is downloaded and installed, after that you see the main application getting downloaded and installed. So over here you see that okay, so we'll have to go by the time frame 11:15. Okay, so over here you see that 11:10, the very first thing that happens is at 11:10 that download and install of Skype application starts, and then over here Skype is downloaded and installed successfully, and then the IME discovers at 11:13 that there is another application, 2 of 3. The second dependent application is Chrome. So Chrome is starting at 11:13. Download of Chrome is starting at 11:13, and Chrome is successfully installed at 11:14. So over here you see that Skype is installed, Chrome is installed. Both were dependent application, and then it finds out, the IME finds out at 11:14 that there was one more application, and that was Fiddler, which is the third dependent application. So over here you see it says 3 of 3. So the download and install of Fiddler starts, it finishes over here. And then finally our master application, which is our 7-zip application, is detected, and then it gets started downloading, and then it gets installed. So over here the sequence is the dependent application are first detected and installed, and then the master application gets detected and installed. And you can see that that is what the prompt at the device end also suggests. So we are starting at 11:10 and we are finishing at 11:15, and in this 5 minutes you are seeing that first Skype is installed, and then Chrome is installed, and then Fiddler is installed, and at the end the 7-zip application is installed, all because the 7-zip application was dependent on all these applications, and only 7-zip was deployed to the devices. The rest of the dependent applications, they were not actively assigned to any user group, but since they were dependent and we had set it to automatically install, they got downloaded and installed automatically. So when we go into the portal, and if we take a look over the 7-zip application, and if we click on this tab called Dependency Viewer, it gives us a very cool looking diagram which tells us that okay, 7-zip application is dependent on Skype, Fiddler and Chrome. And it got this diagram from the policy that we made. So it fetched this information into the UI, and it provided us a pretty looking interface. Okay, and we can change it any way we want to. So if we in turn want that Firefox should be dependent on Fiddler, so what this would mean is even though we have deployed only this application, we have not deployed any of the other applications. Since the dependency is there, so it will say that okay, we will see the same thing. It will do the get policies, and it will identify that okay, there are 4 dependent application. First Fiddler will be downloaded, installed, and then these 3 applications will be downloaded and installed, and then this application will be downloaded and installed, and this will only happen if the detection logic for all of the applications is correct. Alright, and now another good piece of troubleshooting that I wanted us to know is remotely collecting the Win32 application logs. So in our case, we saw that the Win32 logs is all the logs that, there is only one specific log that we are looking for troubleshooting, right? And that log is the Intune management extension log. Now the point here is that the log is present at the device end, right? So if I am the admin, then I'll have to call up the user and tell him that, okay, you know what, go to C drive program data IME folder, and then from there give me the log, right? So again, if there are a lot of users, or if the user is not available, or I mean, if the user doesn't really want us to call him, then it's not really feasible, right? Therefore, we have given another ability that the admin can remotely collect the logs from the end user's device even without reaching out to the end user. If the device is connected to the internet, then the logs will automatically be uploaded from the device, and it can be to the portal, and from the portal it can be downloaded. How do we do that? Well, but what we have to keep in mind is this only can be done if the application installation failed. If it was success, then there is no real point of collecting the logs, right? So over here you see that there was an app. I go to a device. I had a device called Win40. I go to the device, and then I'm at the normal blade which says overview properties. So over here, if I go into the applications tab, the managed applications tab, I see that there was this Firefox application. If I click on this, then you see that there are that the application installation failed. So over here it's giving you the entire timeline, that the admin created it on 31st of July, and at this point this change was made, and at this point it was assigned to an actual group, and at this time and this point the application installation failed. Okay, and after that the device checked in because I ran a sync from the device end. So if the app installation failed, then over here you see that this option is not grayed out anymore, which says that collect logs. So now by clicking on this option, the admin can initiate collection of logs from this device, right? All that needs to be done is that the device needs to be connected to the internet, right? So which obviously it is, because it's being managed via Intune. It should not be powered off, obviously. So if I click on collect logs, then I have to tell Intune that what log do I want Intune to fetch from the device. So in my case, I wanted to fetch the C drive program data Microsoft Intune management extension logs. This is the location, and then I wanted to get hold of the Intune management extension.log. Okay, so I just have to provide the path, and then I have to click on OK. Once I do that, once I click on OK, then I'll see a prompt which says that app log collection initiated, and I'll be able to see this in that timeline also. So it might take, so over here you are seeing that app log collection was started at around 12 p.m. Okay, and once that happens, then we will, once the app has been uploaded by the device to the Intune service, it might take some time depending upon the size. Over here it took quite a lot of time, around 10 plus minutes, and in about 10 minutes we see that the log file has been uploaded from the client, and now this option is not grayed out anymore. Earlier this option was grayed out, right? The download log files. Now this option is not grayed out anymore. If I click on the download log options, then the log will start getting downloaded, and we'll see a prompt like this, and then it will automatically save it in our local storage, and then we'll be able to see the files. So this is the Intune management extension log file from the end device. So this is the log file from the Win40 device. This is equivalent to going into this location and then copying the log file and then giving this to the admin manually, right? So this is useful because now we are no longer reliant on the end user to share his screen and show us the log file or provide us the log file manually. This empowers us to, as an admin, this empowers us to fetch the log files automatically from the portal end itself, right? So it's a really cool feature. All right, so now there is another little tool that is called Universal Switch Finder. I found this interesting because I mean, there are, okay, so we have already spoken about this, but just to reiterate, let's just say that there is an application which we want to push as a Win32 application. Then again, what was the prerequisite, or what was a mandatory thing? The mandatory option, the mandatory thing was we need to be sure that the application supports silent installation. Now, whether an application supports a silent installation or not, and if it does, then what are the switches that are supposed to be used? This is something that we are supposed to find out, right? And it is not dependent on Intune, right? All we are doing is we are supplying the same information via Intune. So, well, obviously, then the task at hand is finding out those switches. So For example, if I want to install Google Chrome or Firefox or VLC Media Player, then usually what happens is if I go into the documentation for Google Chrome provided by Google Chrome, or if I go into the documentation for a VLC Media Player provided by VLC Media Player. So if I'm going to their documentation, then more often than not, in that case, from their documentation, we can find what are the switches and the parameters that a specific application will be supporting, right? So we can get hold of that information from there. It might need a little, it might involve us spending a little time to do that testing and to find that out, because we'll have to go to a third-party documentation. But there is this tool which helps us in some cases. This is a free tool, we can get it from the internet. All we'll have to do is we'll just have to provide the file path. So any MSI or exe that we have, we just have to go to this option, and then this tool is called Universal Switch Finder. We just have to click over here, and we have to point it to a MSI or exe, and it will automatically detect what are the switches that can be possibly used. Okay, so if there is no switch that is detected, like over here for Firefox, you see that there is nothing that this tool detected. Well, in this case, we don't have any option, right? We'll have to go to the Firefox documentation, and then we'll have to search over there, right? So I'm not saying that this is foolproof, but well, we can give this a try, right? And even if we are getting the information from this tool, always the best practice is making a note of this command, going to a device, copying this MSI, running this command manually to make sure that the application is actually getting installed silently without any user intervention. But this is just a little nifty little tool that we can use, which might help us in some cases, which I usually tend to do. Now let's just take a look over common errors. There are quite a lot of them, so we will very quickly go through the common errors that we can probably see on a Win32 app deployment scenarios.
Again, guys, this is just a few of them. There might be n number of scenarios, and we will probably try to talk about most of them, if not all, during our demonstration. But these are some things, some error codes that I found on the internet, and probably it's good to take a look over. So on very rare cases, we will be seeing that there is an issue with unzipping the downloaded content. So the content that we download from the CDN, and after that get policy happens, it is downloaded and then it is unzipped and decrypted, and that decryption information is there in our XML. So usually there is no issue with that decryption, because the key because that information that is needed to decrypt is already there in our XML, unless and until we have messed or we have made any changes during the encryption or decryption process. If there are any issues with the physical resource, or if the disk or RAM has been exhausted, then we might see some error messages as well. And if there are any unknown failures, if let's just say, for example, the app exited with an exit code which we were not aware of, or there was a unknown exception, in that case we might see some errors as well. There is a retry limit for IME as well. So usually it is supposed to retry in every 5 minutes for at least 3 times. So we might be seeing some odd errors if there is any exception. And then there are some issues. We might be into circumstances wherein there are issues with the network connectivity. So this is, very common, because let's just say that our devices are not there in the open internet and we are behind a proxy. So in many cases, we have seen issues with Win32 app deployment, wherein the URL to which the device is trying to reach out to, it is not whitelisted in their proxy, and therefore, it's not whitelisted in the firewall, and therefore we run into many kinds of issues. We have seen instances wherein if we connect the same device to hotspot, everything works fine. That is wherein we might have to take a network trace, and we might have to look into that. And if the system goes to sleep due to inactivity, that might lead to some errors. I have not tried this out, but probably something to keep in mind. And we have already spoken about this, the importance of detection logic. If detection logic is wrong, then the app installation might not even begin, and we have actually seen that use case in one of the logs, right? So that is how important the detection logic is. And we have already said that for Win32 app deployment, IME will not re-evaluate the application status if the app deployment was available, only if it is set to required that the app status is re-evaluated and the app download is triggered by the IME, right? And we have already spoken about the network issue, so this might be something that we need to keep in mind. And detection logic is also what we have spoken about. If the device is moving into hibernate or speed or sleep, we have also spoken about this. There might be issues due to antivirus. So I mean, doesn't happen always, but if we are using any third party antivirus, then it might lead into a situation wherein the application is not getting installed properly. So I mean, my best bet would be getting a similar device with the same network connectivity, the same privileges, having the same antivirus, and then installing it manually to make sure we get hold of the install and the uninstall command, the detection logic, so that all this can be used again. Okay, so I know that there has been a lot of talking, so now let's just get right into it and start with the demo. Okay, so we are going to start the demo with something very basic. So this is my client machine. Let me just show you guys the host name and WinVer. It's running with Windows 10 1809. So first we'll be doing a normal installation of Win32 file. We'll be taking a look over the logs, and then we will be complicating things a little by bringing in by bringing in PowerShell script into the detection logic and bringing dependencies and all that, right? So let's just try and install Google Chrome into it. So I have the Chrome setup.exe. Again, why do we need to do this? So we have two ways of installing Google Chrome on a Windows 10 device, right? First is deploying this from store. If I don't want to do that, then there is only one other option, right? Because this is a .exe, therefore it needs to be converted into .intune win file and deployed as a Win32 application, right? That is what I'm going to use. Before that, as I have already said multiple times during a prod scenario as well, before we deploy an application from Intune, first we need to make sure our detection logic is correct and the switches that we are using is correct, so as to ensure that the application supports silent installation, right? That's what we are going to do now. But I'm not aware of the switches that Google Chrome supports, right? So if I use my nifty little tool switch finder, it might give me the switches, it might not. So let's just give it a try. And over here you see that it does not give me the switches that needs to be used for installing Chrome. So in that case, there is only one other option left, that is the foolproof option, by which we are going to find out what are the switches this application uses, and that is Google. So I am going to go to Google and I'm going to ask Google that what are the switches that we can use for installing Google Chrome. And what are the answers? Well, the top, I mean, again, this is, I mean, not the best way of doing it. So the best way of doing this would be going into the documentation of Google Chrome, because that is the only resource that we can trust, right? And see how exactly Google Chrome can be installed as per the documentation of Google Chrome, right? But I know for sure that whatever I'm seeing over here is correct. So over here it says that if your setup is chrome_installer.exe, then if we use /silent and /install, it's going to work. I know for sure this works, so I'm not going to really waste time in going into any other location. But yeah, I mean, the best way to substantiate this would be going into the website of the vendor and checking their documentation. Okay, so now that I know how Chrome needs to be installed, that is what I'm going to do it now. So apples.cpl, Chrome is not already installed over here. So let me just open up the command prompt as an administrator. And then I am going to go to this location, which is C drive temp, and then C drive EAI. And then I'm going to install the Chrome setup. And then what were my commands? My commands were /silent and /install.
So I'm going to do a /silent and /install. Okay. So you see that there were no prompts that I saw after I ran this command. I believe something is happening at the background. I'm not exactly sure. Let's just open up a task manager. Okay. This is the one that is running. So I can, if I do a procmon trace over here, then probably that will show us that the installation is actually happening. But I don't want to get into very details of that because I know for sure that, I mean, that is not what we are troubleshooting. If this command did not work, right? So then this is wherein we need to do a quick check and we need to do a pause here. We need to make sure this is working locally before we explore the avenues of doing this via Intune. If this failed for any reason, then that's a stop and a pause over there, and this is what you need to troubleshoot first. But we know for sure that this worked because I'm able to see the Google Chrome application over here, and the Google Chrome is launching as well, which means that it was installed successfully. So first step is done, that is I know the install command. Right. The second step is finding out the detection logic. And for that, I need to know where exactly the folder for Google Chrome is installed. If I'm going to use the folder or file as the detection logic, I can use registry as well, but I really don't want to use that. So over here, I see that there is something called Google Chrome, or the best way would be launching Google Chrome and then going into the task manager and then doing something like a open file location. It's running inside C drive program. This is the location, right? So let me just go to this location, x86 Google Chrome application, Google Chrome, and then application, and then there is something called chrome.exe, right? So I got what I needed. Let me just make a note of this. This is what I am going to use for my detection logic. I mean, the intent here is showing you how this is done for any application. Therefore, I'm just doing it live rather than just showing you guys any documentation, right? And I have the installation and the uninstallation command as well. This is, I mean, I just needed the installation command, and which is this. Okay, so I have the installation command, I have the detection logic. This is all I needed, right? So I'm just going to open a notepad over here. I'm going to paste this. So now all that needs to be done is I need to install the Intune WinApp, download the Intune WinApp utility, and then I'm going to convert this .exe to .intune win file, and then I'm going to deploy it from Intune, right? So how do I download this? So I'm going to go into Google and I'm going to say that download Intune WinApp util, and then it should take me to the GitHub account. I mean the GitHub location, and this is the tool that I need. The repro has been deprecated. I'm not exactly sure what this is talking about, but this is the tool that I need, the Intune WinApp tool, right? So the Intune WinApp packaging tool, right? So we just need to download this from that location, and once we have done that, probably I am going to go to C drive and then temp, and I think I should have the tool with me somewhere. Yes, this is my tool. So I'm just copying my tool, and this is the setup file. Okay, perfect. So this is the tool that I have. Now all that needs to be done is I need to run this tool and I need to provide all the information, right? So let's just do that. I'm going to open up CMD as an administrator, run as an admin, and then obviously I need to provide the source path and the destination path. So over here, let me just create a folder called Win32 source, and I'm going to create another folder called Win32 destination. Okay, we have to make sure that there is only one file that is present inside the source, and that is the file that we actually need to that is the file that we actually need to convert to
the .intune win file. I mean the Intune win extension. So I'm going to paste the Chrome over here, and then let's just do this quickly. C drive temp EAI Win32 source. Nope, not exactly this. I need to run the Intune WinApp utility, right? So I am going to run the Intune WinApp utility. It's going to ask me for the source folder. So this is my source folder. So I'm going to provide the name of the source folder over here. It's going to ask me for the name of the setup file, which I am going to provide here. Come on. And then it's going to ask me for the name of the output folder. This is the name of my output. This is the location of my output folder. There is no catalog folder, and it is done. Okay, so now you see that this has been done, and if we take a look over this log, it actually tells us that what is it that it did. It actually encrypted it, and that encryption information will be there in the detection.xml file, which we'll be taking a look in a while. And then you see that all these processing happened. It will tell us the exact amount of time that it took, and then at the end it will tell us that it was generated successfully, right? So just make sure that I'm in the source folder, destination folder is all fine, right? So this is the file that I had. So let me just copy this, show you guys something real quick. So what I'm going to do is this is a file that I just created. I'm going to change its extension to a .zip and show you guys what this file contains. So if I go inside this file, I see that this contains, as we have seen already in the presentation, it contains two folders. One is contents and the other is metadata. If I go inside contents, I can see that the Intune package file is present. This package file is the setup, if you would call it, for installing Chrome. And the metadata contains the detection.xml. So we can actually open the detection.xml in Notepad and then see what this contains. So this contains the size of the application that that the setup contains, and the name. We know that the name of the package right now is Intune package.intunewin. This is actually the setup file for Chrome. Over it says that Chrome setup.exe, and then we see the encryption keys. This is what the IME is going to make use of when it needs to decrypt that package, right? And then there are a couple of other keys, and what else is there? Nothing else. That it's telling us what was the algorithm that was used to encrypt that package and whatnot, right? So I mean, nothing much that we needed to do over here. So now I'm going to quickly go to my portal and then show you guys how to deploy this application. Okay, so I am logging into my portal now. I'm going to go to apps, and then I'm going to go to all apps. And this is how we make a Win32 app deployment. So I go to add, and over here I select Windows app Win32, and I do a select. And then I have to provide the package file over here, and at one place. Okay, so it's telling us that what can be the input file. It says that can be .apk IPA. I mean, it would have made more sense if over here it said that you need to upload a .intune win file. It doesn't, but yeah, so be it. So I'm going to go to C drive, and then temp, and then EAI, and then Win32 destination, and this is where my Intune win file is present. I'm going to upload it. Over here, it automatically identifies what is the name of the setup, is whether MAM is enabled or not for this application. So I'm not going to get into that. We don't need it. Okay, so now we have to provide these mandatory information while we are deploying any application. It tells us what's the name of the application. So let's just call it EAI Chrome, and and the publisher is Google. Category, and well, I'm deploying it as a required, so I don't necessarily need to show this as a featured app, but if I need, I can provide the information, URL, the privacy URL, the developer, the logo, and all that, right? Okay, so now comes the important part, the install command, right?
So I know that this is the install command. I necessarily don't need the uninstall command. Uninstall command is needed when, when we are, so from Intune, we can push this deployment, push this package for installation or for uninstallation of the application, right? So I'm going to use this for installation. Therefore, I'm going to put the same thing for the uninstall command as well. But for my case, it doesn't necessarily matter because it is just the installation that I'm focused on right now. And then the device restart behavior, I don't want any action to be taken because I know that for Google Chrome to be installed and for Google Chrome to work successfully, there is no device reboot that is needed, right? So I'll just do a no specific action needed, and the return codes would be the default ones. We do a next, and over here we put in the requirement rule. So what is going to be the requirement rule? So we have some basic ones. Minimum operating system we can put in Windows. So I know that my machine is running with Windows 10 1809, so I can just put in Windows 10 1709, and let's just say that 101 MB free space should be needed, and 101 MB of RAM, of free RAM, should be needed in the device, and that's it. If you want, you can just add in a script as well, which is going to do this detection for us. We are not going to do that now. We will complicate it later, but for now, this is what we are going to put in. And then over here, this is when we put in the detection rule or the detection logic. We are going to first go with the manual one, and over here we have to configure what kind of rule we want. We want a file. Okay, so the path of that file, what is the path of that file? This is the path, and let me just put this in. And file or folder exists. What is the file? This is the file. File or folder exists. Detection method, file or folder exists. Okay, next. And then dependencies, I'm not going to go into that right now. And over here we have an option to put in required, available, or uninstall, right? So that is why we need the uninstall command, right? If the application needs to be uninstalled. Right now I'm focusing only on the installation part. So let me just do this. Let me just deploy it to a group. Okay. So everything looks fine now. The application, it says that the application is not ready because the app probably is uploading, but that is absolutely fine. I mean, so over here it just says that the upload finished a few seconds ago, and then you see over here that it is ready. The application is ready. Okay, so I think we are ready for the demo. So all that needs to be done is, well, any guesses? Well, all that needs to be done is the device needs to be enrolled, right? And before enrollment, the device needs to be either Azure AD joined or hybrid Azure AD joined. So I'm going to do the easy part. I am going to do a Azure AD join of this machine. Obviously, let me just get rid of the Chrome application first. Just need to make, well, only then the Chrome application will be installed by Intune, right? So yes, this has been uninstalled. Let me just go to C drive, program files, Google. Okay, so these, I can just delete the Google folder as well. Okay, perfect. So I think everything is there in place. Let's just enroll the device. I mean, Azure AD join the device, enroll it, and then we will be taking a look over the logs. So how do we do a Azure AD join of a device? We click on start. I believe we already know this. We're going to click on connect, and then over here we are going to do a join this device to Azure Active Directory. And I am going to enter test at the rate everything about intune.com and my password 75781. Once this is done, once the device is Azure AD joined, I will be able to log into this machine using my Azure credential. And you see over here that the prompt is similar to the prompt that we'll be getting while we join a machine to the on-premise domain, right? So I'll just do a, I mean, not that a reboot is needed, but I'll just do a quick reboot of this machine once the device is Azure AD joined, and then we will be taking a look. So so the reboot of the machine is happening. Again, I mean, I'm assuming that we know the difference between Azure AD join, Azure AD registration, and hybrid Azure AD joined. If not, then I'll suggest let's just take a look over the video that I've done on Windows enrollment. Probably that should help.
One more prerequisite for this to happen is the MDM scope needs to be set for the user, right, to all. So over here you see that now I have an option of signing in with other user, and that other user is test everything about intune.com, and then earlier I was logging in with a local account only. Now I can log in using a domain account. Everything about intune.com about okay, well, I need to spell it right, only then I can log in, right? All right then. So we are going to log in. The deployment is already made, and then we are going to monitor this very closely, and then we are going to see that first Intune management extension gets installed, and then the prompts that we get, the toast notifications that we get. So I'm going to remove all the toast notifications from here, and and show you guys that right now the Intune management extension is not there. Well, the fiddler is there, which I don't really need on this machine because that is something that I'll be deploying later. Uninstall. Yes. Okay. Right now we can see two things over here which is important. First is Google Chrome is not there and the Intune management extension is not installed, right? So what I'm going to do, I'm going to go to start and then settings, and I'm just going to run a sync from there, and then I'm going to monitor this very closely and then show you guys that when the Intune management extension comes in, and when it does, you'll be able to see that Intune management extension shows up over here as well, right? So let's just give it a couple of seconds, and then we will refresh this page and we will see when the Intune management extension gets installed. This is what I wanted to show you guys. The very first thing that I wanted to show you guys was the Microsoft Intune management extension has been installed, right? And if I go into start and then settings, and if I do a info over here also, I see that Microsoft Intune management extension has been installed. So we don't need to push this extension. When we are pushing any Win32 app or when we are pushing any PowerShell script, this gets installed automatically, just like we don't need to raise a case for Mintech to go. We just need to raise a case for the hard disk replacement, and it goes without saying that it is the Mintech guy who's going to do it for us, right? So Mintech goes by default. We are waiting for the toast notification for Chrome download and Chrome install. And once that is all done, we will at the end be taking a look over the logs. But for now, we can see that Intune management extension is there, right? So which means that things are headed the right way. So if I go to my account here, over here also I'm able to see Microsoft Intune management extension, right? All right, cool. So at this point of time, I'm assuming that the Intune management extension, that is our remote hand guy, he would be calling the admin sitting in the remote location and be telling him that, okay, you need a hard disk replaced. Tell me all the information related to the hard disk, which is equivalent to doing a get policies. And over here, you see that we have started getting the prompts as well, which says that everything about Intune software distribution and your IT department requires changes. And then it says that it is downloading and installing the software EAI Chrome. Okay, so the download and installation has begun. We will not be seeing any other prompts other than once the installation is done, the detection logic will run, and then it will tell us that okay, there you go, the installation is done, and now the exit code will be monitored and the detection logic will be getting hold of the exit code, and then we should be seeing another, yeah, there you go, we are seeing another toast notification over here that the installation was done successfully, and now the information will be sent back to the Intune service, and obviously the detection logic ran successfully over here as well. Now if I run a refresh over here, I'm able to see the Google Chrome application, and well, obviously the detection logic was successful, which means that under program files x86 Google Chrome, this file is there. So now let's just take a look over the logs and see what exactly happened in the logs. I'm going to go to Microsoft Intune management extension logs, and then let's just get our hands on this logs. Let me just paste it over here and let me just run this log, right? And now the important part, whatever we saw in the presentation, whatever logs we saw, we will see exactly the same thing is happening over here, right? So I'll be doing the detail analysis of the log only once, because this is the first time, and then we will be just seeing at the difference. So over here you see, as we saw in the block diagram, the EMS agent is started, and the timer is getting set, and then at one point it will be checking whether it is S mode or not. That's what it is checking over here. And the content manager is starting over here, and then it is saying that my device is not running in S mode. Okay, because it checks for S mode, because S mode is a mode in which a device can run only with the store applications, not with, I mean, a S mode device cannot run with any exe that we are sideloading or deploying like this. There is a way. So if you have a S mode device wherein you want to push a Win32 application, it can still be done. I'm not going to get into the very details of that, but the Intune management extension makes a check for that. And then it's the host service is started, and let's just see, EMS initialization is done. The scheduler starts over here. The impersonation starts for the user, and you can ignore these alerts. I mean, ignore these error messages. That's all fine. Over here it says that after impersonation, this is the ID that I have used to already join the machine. And let's just keep going down. Over here we see that successfully get the token with the client ID. So it got the token that it needed. You can keep going down. This is the user ID. The service URL is not available. We can ignore that one. Okay, we can keep going down. We'll be taking a look over the registry also later on. But okay, this is the Intune download service URL. So this is one of the service URLs wherein our device reached out to. So we keep going down. We see a repetition of the couple of logs over it. All again says impersonating the user, and we see the same URL again once, which is absolutely fine. Over here it's doing a get policies, but for the first attempt it says that got 0 scripts for this user. That is absolutely fine, and we will keep on going. And at one instance we'll be seeing that when it does a get policies, it's able to get the policies that was deployed to this user, right? So first time intake guy calls, nobody from the remote location picks up. No admin is there who's picking up and telling him, okay, this is what you need to do. He calls a couple of other times, the polling keeps on going, and then eventually he's able to get hold of somebody, right? So that is what is happening over here. I'm going to keep on going down, and I'm looking for I am looking for the get policies, or there's the better way of doing this as well. That is, I can just do a Control F for get policies. But for now, I just want to, I mean, parse through the logs in front of you and show you guys what is exactly happening. Okay, so over here you see that the impersonation happened again. Everything was fine until here, and it sent a put request, and over here something happened. I'm just trying to make sense of, yes, this is the one that I was looking for. At 1:14:07 p.m. we see another get policy request, and let's just copy this. We have already seen what is the content of this information, but in the slides, but let's just do it again. So over here it says that we got a policy, get policy. This is the name of the policy that came down. The detection rule has been set. Therefore it's saying the detection type is 2, and this is the location which is my detection logic. If I was using a PowerShell script, then I would be seeing something else over here and something else over this. Instead of 2, there would be something else. And what else? The installation intent is here 3, so I'm assuming 3 corresponds with required. And then I see the installation command line and the uninstallation command line. And then we see the requirement rules as well, which was set. So I see 101 MB of free space. And 101 MB of RAM should be there. Maximum retry counts is 3, and maximum runtime in minutes, this is 60. This is all by default. Return codes were what were configured by default, so I did not change the return code in the policy. And well, not else, so nothing else. So what I'm trying to say is this, the get policy contains all the information which was there in the policy to begin with, right, which the admin had configured. And then over here it says that got one Win32 app for the user, right? This is the user ID, this is the user ID of the test user. Okay, it got one app because, well, obviously there was only one application deployed, that was Google Chrome. Okay, so I keep on going down, and then it says that get one Win32 app initially. Over here it would make a check now for the dependencies as well. In my case there are no dependencies, therefore there is only one. Over here it says that finish process dependency resolved action with count 0. There are no dependencies for this application, therefore it's good to proceed. And if I keep going down, few of the logs, you will see that it repeats. So over here you see that the impersonation happens again, that is all fine. The dependencies were not there, that is absolutely fine. And now it is over here it gives us this line which tells us that app with name EAI Chrome dependency detect only is false, which means that there is no dependency. And then this is the app ID, and then it says that detection rule. Now it's going to detect that, okay, there are no other dependency on Chrome, let's just install Chrome. But before we install Chrome, let's just make sure whether Chrome is already installed or not. If Chrome is already installed, there is no point downloading and installing Chrome again, right? Therefore detection rule start, and then the detection rule manages goes through the parses the install ex, and over here it's going to evaluate the detection logic. The detection logic that we have is path file and path exists or not, which is C drive program files Google Chrome application chrome.exe. This is what we had put in the policy as well, right? So obviously at this point of time, this file is not there, and this folder structure is also not there. Therefore application detected is false, meaning this application is not detected, and detection logic was false, right? Which means that now it's going to check the applicability, and the applicability is the OS structure and all that information that we have set, and the application in this case is applicable. Over here it's checking for the memory that needs to be there, and the total memory and the total free space that we have set in the policy. So it's checking whether 101 MB of free space and 101 MB of RAM is there or not. Then it checks for the extended requirement rules, we haven't set any, therefore it keeps on going, and then it will start to download the application at one point. So over here it's telling us what was the reboot status and all that information, which was set in the policy. That is absolutely fine. And now that it is setting the download timer, and now it is going to do the impersonation again, and this is a toast message that we got. So if I go into the device, I got this toast message, right? The very first toast message, the very first two toast messages. This is what this toast message is signifying, right? There was a toast message which says that your IT administrator requires you to make changes to this application or something like that, right? The very first one. Your IT department requires changes to this application or whatever, right? So the first toast message comes up, and then the download is starting over here at 1:14:08. So you see that so many processing is happening at the same time, right? So it's very fast. So over here it says that it's downloading the app. This is the application ID that I have set up in the portal. So if I go into this application, this is the application ID ending with 3A, right? That is what we see over here as well, the application ID ending with 3A. Right, and then it's getting the content from Intune, and then this is the place wherein it got the application ID. We can just it downloaded the application, so let me just paste it over here, and then it says that the content info request is application ID ending with 3A. That is the application that I downloaded, and then the intent, it is sent again. And then the certificate blob, because, well, obviously the application is encrypted, right? So from the detection XML, it's going to get hold of how to decrypt this application, right? And then the timestamp and all that information is also there, right? So moving right along, if I go further, the impersonation happens again. The impersonation we see happens for a couple of times. not just initially. And then it is getting a lot of other information as well. We can just safely ignore this, and we'll keep going. And I am, so at this point of time there is another toast message which says that download the toast downloading message, right? The second one that we saw, the second one, which is I hope I did not, I think I have cleared that notification, but the second notification that we saw which says that the download and installation is starting. So over here you see that starting downloads at this point of time. The application that we have deployed ending with 3A, the download for that is starting, and a download job has been created as well. This is the application that is being downloaded. Okay, so what happens is initially it comes to this folder. That is, let's just go to this folder right now and see what is it that we see in this location. So C drive program files. So I'm going to go to C drive program files, and then Microsoft Intune management extension, and then content, and then incoming. So content, if I go to incoming, you see that the time is the latest one, that is 114, which corresponds with the time at which what we are seeing in the logs as well. But the folder right now is empty. But what I'm trying to say is next time when we are downloading, I mean, when we are doing this repro, what we'll do is we will keep this location open so that we are able to see the incoming file which comes to this location. But right now you see that this folder is empty, but the timestamp signifies that there was some changes made to this folder, right? So this is the initial location to which the file is downloaded, and it is later on flushed after the installation is done. This is the download job ID. And if I keep going, once the download is done, over here download is starting, and once the download is done, it is waiting for the job to complete, and once it is done, the timer will stop. So over here it says that notified DO service that the job is complete. Over here it's telling us what is all the information that happened, the download duration, and what else is there? The file size. This corresponds with the size of the file that was uploaded to the portal. And all right. Okay, let's just keep going. So over here, first, once the download is done, well, obviously, as I said, that the file is encrypted, right? So over it is verifying the encrypted hash. Once the verification passes, that verification that the file is signed correctly as it was during the upload, then the decryption will start. It will make use of the keys that was there in the detection.xml to decrypt the file, and over here we see that the content is decrypted, right? See a consolidation of all that happened, the download file, that the time that it took and the size of the file that was downloaded. And well, obviously the download is done, the file has been decrypted. Now that that package can be unzipped. So it's trying to unzip, and now you see that the file is moved to another folder that is staging and then IME cache. So what I'm also going to do is let's just make a note of all these locations so that next time when we download and when we deploy the other application, we keep all these files and locations open in front of us so that we can see the magic happening under the hood. And then it's cleaning up the staging folder, that's why it was removed. And then we can keep going down. Over here, if any retry needs to be done, then we will be seeing that the retry is done. For us, there is no retry that is needed. This was the installation command. So now the installation, so everything has been downloaded, decrypted, detection rule, everything has been taken care of. Now all that needs to be done is the application needs to be installed, right? So over here we see that execute with retry parsing install exe, and now the installation is beginning, and we can see the command that was there in the application deployment, which is going to run for the application to get installed. Okay, all right. So over here you see that it runs in machine session because that is what we selected in our policy. And then there is a process ID that has been created to track the installation. And over here we see that the timer has been set for the installation. We keep on going down, and then over here we see that the installation is done. So at this point of time we don't know whether the installation was successful or not,
but we know for sure that the setup did run successfully. So we can keep going down, and then it says that IP exit code is 0, which marks a successful installation, right? And then depending upon what we had set in the portal, that I mean, if the exit code is 0, whether you want to restart the machine or not. In our case, we are not running any restarts. Okay. All right, so we can keep going down. IP exit code is 0 is defined as a success, which is good. We can keep going down, closing the handle. All right, changing the current directory back to C drive Windows System 32. And now obviously the installation is done, but we don't know whether the installation was successful or failed, right? So obviously it's going to run the detection rule again, the detection logic again. So the detection logic runs again by parsing the install ex, and over here it checks the same location again, that is C drive program files, Google Chrome application. It sees whether this file now exists or not. In our case, it does. Therefore, we see that application detected is true, which is good enough for us. And now we see that it is, I mean, it's the same command, it's the same line again, which is saying that it is checking under this path, and it is seeing whether this file is present or not. And it was able to detect it, so everything looks good. The detection was set, I mean the application is detected, and now we see that the compliance message is sent. So this is wherein we are updating a couple of registry locations, and we are telling Intune service that, okay, you know what, the installation was done successfully. And then it says that it is removing the content from this folder. So again, during a successful installation, we should be able to see that the content from this folder gets removed at some point, right, in the incoming folder. Okay, so let's just keep going down, and then we see there is an enforcement message, and this enforcement message is actually a toast notification. So we saw a toast notification which told us that the app installation was successful, right? So this is pretty much that. And what else? Okay. All right. And then it's going to do the same thing over and over again during its polling. It's going to do a get policies again, and if there are any other get policies that it identifies, then it will get those policies and it will do the same behavior again, right? So over here we see that when we come into the portal, it says that the status is install pending. That is absolutely fine. Maybe our portal is not aware yet. We have an option of downloading the report from here as well. If I download the report and if I open it, I can see the same information, that what is the device name, the user, the platform version, what is the status, and all that information, right? So that is absolutely fine. Probably we can monitor this for some time, and then eventually we'll be able to see that this shows as succeeded, because the installation was successful and the detection logic was also successful. So this was again a quick ramp up of what needs to be done from the portal, how the application needs to be deployed. We all saw this again, how the Intune WinApp utility needs to be utilized and how it is deployed when it comes down to the device, what exactly is happening, the toast notifications that we are seeing, and what exactly is going through in the live dig deep. We did a live understanding of the Intune management extension log, and above all, most importantly, the very first thing that we did was we installed the application manually and made sure that we are sure about the detection logic and the installation and the uninstallation commands, right? So now we are going to complicate things a little, and now what we are going to do is we are going to talk about dependencies. So what we are going to do now is, first we will be deploying the Chrome application and the Firefox application, and Chrome will be dependent on Firefox. However, before we do that, the same drill again. So let me just make sure I get the detection logic and the installation and the uninstallation commands right. So sorry. Okay, so this time I'm going to do it fairly quick. So /Firefox, and then I think just a firefox.exe/s works. I've already checked this, but yeah, I mean the exercise would be the same.
going into the firefox.exe, going into the Firefox documentation and then making sure that whatever switches that we are using is correct. So Firefox seems to be installed. I'm going to go to C drive and then program files. And do I see something called Mozilla? The best bet is always launching the Firefox and then from Task Manager getting a hold of the install location and stuff, right? So I'm going to expand this and then I'm going to go to open file location, which is C drive program files Mozilla Firefox. So let's just go there. C drive program files and then Mozilla Firefox, and then over here the exe should be there, right? Cool, perfect. So I'm going to make another deployment. This time my deployment is this, rename, copy, and my installation command is /s, right? So this is all I needed from here. So now let's just do a deployment for Firefox. So I'm just going to go into my portal and now let's just go to Firefox. I've already taken the liberty of converting it. So if I go into the process of converting firefox.exe to .intune win file is the same as the process of converting the setup for Google Chrome into Intune win file, right? So I'm not going to waste time in showing you guys that. So I already have the firefox.intune win file. So what I'm going to do is I am going to create a deployment for Firefox. So I'm going to go to Win32 app and then select. We'll make a little change to the deployment this time. So the change that we are going to do here is let's just go to temp and then Win32 and then output and then Firefox.intune win file and then OK. Over here, let's just call this EAI Firefox. Everything is fine. Firefox. All right. Now let's just put in the install command, which is the install command is fairly straightforward, which is this. Already seen it works. An installation command necessarily don't need it, therefore I'm not going to waste time in finding that out. Device restart behavior, let's just do a no specific action needed. Return codes are fine with me. Operating system architecture, both are the requirements. Minimum operating system, so let's just do the same 1709. Disk space, in this case I will do 102 MB so that we can see the difference. For Chrome we have 101, for Firefox we have 102, right? Rule format, manually configure the rules, and then the rule type is file, and the path is, let's just get hold of the path, and then the file or folder exists. This is the file that needs to exist, and then OK. Next. Dependencies, I am not selecting any. So Firefox is not dependent on any application. And what you will see here is I'm not selecting any dependencies. And most importantly, I am not assigning the Firefox application to anybody. Okay, so I just do a next, and I do a create. It has been successfully created. The app is not ready yet because the app is still being uploaded. So once the app is uploaded, then I'll show you guys something interesting. Well, it is around 50 MB in size, therefore it's taking it's taking around 30 seconds to upload. Once the upload is done, then I'll show you guys a nifty little trick here. Okay, so now what I'm going to do, I'm going to go back into Chrome, and over here for Chrome, I'm going to add the dependencies. So I'm going to go to dependencies and then add. And over here, I'm going to add the dependency on EAI Firefox. Okay, I do a select, review, and then save. So what this means is I have only deployed the Chrome application. I have not assigned it yet. So I removed the assignment. So let me just do this. Let me just add the assignment for Chrome back. So Chrome has been assigned back over here. So let me just tell you guys again what is it that I have done. Probably what I'll do is I will show you guys again from start. Meaning I will unenroll this device and then enroll it again. So let me just go to accounts so that we are able to see the, okay, it's not enrolled anymore. And I go to appwiz.cpl. Chrome is not there anymore. Firefox has been uninstalled. Perfect. So everything is ready now, apart from the fact that Firefox was not closed. Come on, come on, come on. And this time we are going to go open up that notepad file and tell you guys how exactly the setup file is moving from incoming to all those locations, right? Cool. So Intune management extension has also been removed. Perfect. So I think we are all set. The point that I wanted to make here, guys, that let's just do a quick recap. So in the second scenario, what we are doing is we are checking the dependencies. Over here, what we have done is we just have the Chrome application deployed, and Chrome application is dependent on the Firefox application, right? So, but the Firefox application is not deployed to anybody. We have set up everything in Firefox, the install command, and installation command, the detection logic and all that, but this is not deployed to anybody, only this is. What we will see is that Chrome will not be installed until and unless Firefox gets installed on the device, even though Firefox has not been targeted by anybody. Okay, and then we'll be taking a look over the logs as well. So let's just do this. Let's just quickly enroll this device again, and then we will take a look. All right, perfect. Now let's just quickly open up these locations so that we are able to see the working under the hood. So I'm just going to go to C drive and then program files and then Microsoft Intune management extension and then content and then incoming folder. Right now you can see that the incoming folder is empty. Okay, we will keep on refreshing this. And then let's just open to another window, and this time we will be opening up the staging folder. Right now you can see it's empty, and then the other one is again incoming folder, which we already had. Okay, cool, fair enough. So we are going to keep on refreshing these two folders, and for now I see that the Intune management extension is not yet installed on this machine. Let me just quickly go and run a sync, and then Intune management extension should flow down, and then probably we will see what is happening in those locations as well. Okay, so the sync just ran successfully, and over here you can see that Intune management extension is installed. This is wherein we are hoping to see something coming into these two folders. So I will be refreshing these two, and then we will be seeing, let me just make sure if there is a better way to probably this should help. Yeah, all right, this looks better. So I'm just going to keep on refreshing, and what we have to see is whether we are able to see anything in those folders or not, but more importantly we'll be keeping an eye out on the notification. Over here you see that Firefox dependency 1 is being downloaded, and over here you see that something is coming in the incoming folder as well as it quickly moved into the staging folder. So we are able to see that the download actually happened, and when the download happened it actually moved into the incoming and the staging folder. You can see that this is the application ID ending with DC. Let's see what's inside of this. Nothing really. But yeah, at some point we'll be able to see that once the installation is done, this gets moved out. One more important point that I would like to highlight here is that we only have deployed Chrome. We have not deployed Firefox. It is not assigned to any group. But over here you see that it is the Firefox application which gets downloaded and installed first, right? So there is only one dependency. We have not created more than one dependency. So the first application is getting installed and downloaded. We should be able to see a toast notification once this happens. I don't see it installed yet. And over here you can see the size also, right? So when you were uploading the .intune win file, it was around 50 plus MB, and that is the size of the file that has been downloaded over here as well. Now we see that there is this compressed folder, and that compressed folder contains the firefox.exe. This is the file that is getting installed. So we can actually see that the even though we uploaded the .intune win file, when it is actually coming down to the device and it is decrypted, it actually contains a exe at the end, because well, when we are using .intune will to deploy, but to install, well, eventually it has to be an exe which is getting installed on the device, right? So that is what is happening over here as well. So three. Okay, guys, so it seems that a lot of processing has happened now. So if I scroll down, let's just take a look over everything that has happened on this machine. At 4:20, at this time, the IT department, I mean, the first toast notification came, and then the second thing that happened was Firefox dependency was identified. It was downloaded. Firefox was installed at 4:21. And after Firefox was installed, there was another toast notification. This time it was for Chrome, and then Chrome was installed at 4:22. And over here you can see that both Firefox and Chrome has been installed on this machine. If I do a refresh over here, I can see that Chrome and Firefox both are installed. So the point that I'm trying to make is by referring to this sequence as well, we can say that first Firefox was installed and then Chrome was installed, because Chrome was dependent on Firefox, and I mean, until Firefox is installed, Chrome cannot be processed. And if we take a look over the logs, it is going to substantiate the same thing. I'm going to very quickly take a look over the logs. If I go into Microsoft and then into management extension logs, let me just very quickly show you guys that. So let me just delete the old one. Okay, and let me just go all the way to the top and then a control F for get policies. Okay, this is the policy that came down. If I copy this to a notepad file, over here I can see that Firefox. Okay, so over here you can see that the dependency is Firefox. So it says that this is the I mean, it has got one policy. The name of that policy or the deployment is AI Chrome. This is the all the install location and all that information. And the important stuff here is the dependencies over here. You see that the dependency here is new flat dependencies. This is one dependency, and this is the ID of the dependent application. So if I go over here, if I go to apps, and if I take a look over this, the ID of the dependent application 87 ending with DC. 87 ending with DC. This is the dependent application. This is the name, the detection rule that I have put in, and all the information, the install command, the installation command, everything. And over here you see that the requirement rule will also be here somewhere. And if I take a look over the requirement rule, we will see that the requirement rule for this one is it needs to have 102 MB of free space and 102 MB of over here you go, 102 MB of free space and 102 MB of RAM. That should be present, right, as it was there in the policy. So the policy comes down over here. Let's see what happens after this. We will very quickly go through all of these because we have already seen it once. So the token acquisition and all that stuff happens, and over here you are seeing that we are parsing the exe, and the detection manager is starting. It is detecting for Chrome application. Chrome is not installed over here. You can see that the app detected is false. So what happens after that? Let's just keep going down. Over here it finds that there is one other application in this chain. And what is the name of that application? That is Firefox, and this is the ID of that application. So it is first processing the dependent application as per our requirement. It is checking the the detection manager is checking checking whether the dependent application is installed or not. In our case, it is not, therefore it returns false. And then it starts to present the dependent application first. That is, in this case, the Firefox application. The detection rule kicks in and it says that, okay, C drive program files Firefox is not present. Therefore, Firefox will first get installed. In this case, Firefox will be downloaded. This is the first toast message that we see. And if I keep going down at some place, I'll be able to see that the Firefox, EAI Firefox dependency one of one is being downloaded and installed. And this is exactly what we saw over here as well, right? The first one, EAI Firefox dependency one of one, is being installed. So this is the first application that is being processed. The toast notification is there. The application will be downloaded, installed, and there will be we were able to see all those files and the incoming and all these folders. Once this is installed and everything is done, we will be able to see the detection logic running again. So over here, the file is getting downloaded and unencrypted, installed. The IP exit code is 0. The application was successfully installed, and now the detection logic will run again. This is the detection logic running for Firefox.exe, and over here you can see that the detection logic ran true. And since Firefox is not taken care of, now we will do the same thing for Chrome. That is the parent application. And over here you see that detect install. With the mode detect install, over here it is detecting the Chrome application again, and it says that no, Chrome is not installed, that only the dependent application is installed and not Chrome. Therefore it will start the installation of Chrome now. So it is checking the applicability. Over here you can see that it's checking whether the application is applicable or not, the free space that is present and all that. The requirement rules and everything will be checked, and then we will be seeing that the application gets installed. Once the application installation is done, it will inform the service the same thing, right? So if I go into the device install status again, it takes a little bit of time for this to get updated. So if I go into EAI Chrome, okay, I think it is showing as installed now. Okay, so it's showing as installed now. And if I want to, I can export this report as well, which will give me the same information. So the takeaway from this is understanding what exactly dependency is. And if you want, at the end we'll probably be installing all the applications and then making each application dependent on the other, and then we'll be seeing that the applications get installed in a chain. Right. So, but then again, we can have one application dependent on many. In my case, I just wanted to show you guys an easy one. Okay.
Now we will be taking a look over how we can deploy a KB to a Windows device. And this is essentially very, very useful because it gives us the ability of selectively patching, which inherently we can't do via Intune because, update ring doesn't support that. Right. So this is what I'm going to do. So it was a little tough for me to find a KB which is not superseded and which is still applicable on a device. On the operating system that my device is running with, which is I think 1809. So I found this KB. This KB is still applicable on my device, and this is what we are aiming to deploy via Intune. And I have already checked. If I go into the machine and if I do a appwiz.cpl, this update is currently not there, ending with 6.5. So over here you cannot see that update present over here. Right, meaning that the update is not already installed. So this is the KB that I'm aiming to install, and the process remains exactly the same. First, what I'll be doing is I'll be installing it manually. I'm going to skip that part, but the process remains the same. I'm going to install it manually, make sure that it supports the silent installation. I find out Well, again, there is not going to be installation directory per se, so it's not going to create a folder. Therefore, we cannot use that as our detection logic. So that is something that we might have to figure out. But other than that, we just need to make sure that it supports silent installation, and we need to get hold of the commands that we need to make use of, right? And before that, the admin has to convert this into the .intune win file, and the process for that remains the same. He has to make use of the utility that we already have. So I have already taken the liberty of converting it. So this is that file, .intune win file, pretty much straightforward, nothing fancy needs to be done. And I just uploaded it into the Intune portal. So if I come to the apps, this EAI KB, this is the app that I have. And this is again pretty much straightforward. The name, the description, publisher, all that information. The important part here is the install and the uninstall command. Now, how did I identify the install and the uninstall command? Well, I was able to Google this out, right? So the uninstall command is going to be wusa.exe. This is the service. Not exactly the service. This exe slash uninstall slash kb colon the kb number and then slash quiet, and then this is going to be the installation command. I necessarily did not need the uninstall command, but I need to make sure that I've got this right, and I ran it manually on a device as well, just to make sure that it was running fine. So if you have any other kb article, you know what changes are there that need to be made. Okay, cool. So and this name that you see over here, I know this is very long. This is actually the MSU that I had. So probably a good approach would have been renaming this. So over here you see this is the name, right, ending with ATF. So over here it's ending with atf.msu. So if I had changed this to probably something like a abc.msu, then I could have got rid of this entire name, right? So that would have made more sense. But anyways, that is what that was needed to be done from the portal. And over here, one more important thing that we see over here is the detection rule that I'm using, the detection logic that I'm using. And as we know, when we are installing a KB, it's not going to create a folder. Therefore, we cannot use file or folder detection logic. So what do we use over here? We use a PowerShell script. Therefore, it brings us to another important point, that is how to use PowerShell script as a detection logic for Win32 app deployment. So this is the script that I'm going to use. And this is pretty much straightforward. All it does is it runs systeminfo.exe and then finds for this KB article. It finds for this KB. If this KB is installed, then this will be returned, and then we are going to exit with a exit 0, which is successful. Otherwise, we are exiting with exit 1. Write output not really needed because well, nobody's there in a PowerShell session to see what is the right output that is being displayed, right? So let me just do this real quick. Let me just open the command prompt and run the same command once. So if I run the systeminfo.exe, you will see it gives us a bunch of information which includes the the hotfixes installed on this machine, right? So now if I copy this hotfix, and if I do this cls, and then if I do this find str followed by the KB article, the KB number, so my KB is found over here, right? However, if I do KB and then 4465065, well, obviously this will not be found, right? So this is the difference over here right in front of you. And if I go at the background, I can see that a KB ending with 349 is installed, but a KB ending with 65 is not installed. So the point that I'm trying to make is this is exactly what my script is also leveraging. It is first running this exe and then finding the string. If the string is there, then everything works. If the string is not there, if the KB is there, then say the string is able to, the find str is able to find it. Otherwise, it is not. And then we are exiting it accordingly. right? We need to make sure we are exiting with a 0 in case of success and exiting with a 1 in case of failure, right? So now all that needs to be done is this needs to be deployed, and then we'll take a look over what exactly the experience is. So let me just go to edit and then assignments, and then let me just assign it to the same group, and then we will Azure join our machine, and then we will see how exactly the behavior is. So I took the liberty of removing the Azure join, and I removed all the folders and stuff, because I mean I just want to show you guys uh, the files and the logs relevant just to this. So let me just enroll this machine again, and then we will resume. Okay, so the machine is Azure already joined now and is enrolled to Intune, and I'm waiting for the Intune management extension first to come down, and then we will see whether the KB gets installed or not. So I'm just going to info engine, just running a sync. Let me just also open up apples.cpl. We have installed updates, and over here I'm not able to see any updates. Well, the expectation is before the updates come up, well, obviously the management extension should come up over here, right? So let's just wait for that to happen. Okay, so over here we see that the prompts for the software have started coming now. It's saying that downloading and installing recent requires, yeah, restart is needed. So what I could have done is in the policy itself, I could have forced a reboot, which I did not. But over here you see that Intune management extension is there now, and the prompt also came in that recently installed software is this, and a reboot is needed. So if I go to apples.cpl now, and if I go into view installed softwares or updates, then do I have anything ending with 65? Yeah, this is the one ending with 65. The installed date is not there. So I'm going to reboot the machine now, so that the installation so that the effect of the KB takes place, and then I'll be getting my hands on the logs, and then showing you guys that it was the PowerShell script that did the detection this time. Okay, so I'm back at the machine. Let me just grab hold of the co-management handler logs, and then we'll be taking a look over what this log has to say this time. So Microsoft Intune management extension logs, and then the IME logs. And let me just paste it over here. And now let's just analyze this logs to see what would have happened and when. So again, the same drill. So get policies, and then again get policies. Okay, this is wherein the policy came in. Will again not go into the very detail, but we know that we are looking at the right policy because we are looking at the right commands, right? So all that we configured in the policy is here. So I'm going to very quickly go down, and what I wanted to show you guys is during the detection logic, it's the PowerShell script that gets downloaded and assessed. So the execution manager is starting over here, impersonation and all that is done. The requirement rule is checked, and the detection, for the detection rule, you see that it is making use of a script, and that script is the one that we uploaded. It's in the format .ps1. So for the first time we see that, and then there is that toast notification. We already know what this is, and let me just keep going down. Over here you see that the PowerShell script ran successfully, and let me just copy this. I'll show you guys the before and the after difference. So this is what happened before the KB was installed, right? So I just made a note of that, and then obviously over here it says that result of application detected is false, obviously because it was false. And then the KB got downloaded, decrypted, and all that stuff happened and installed. So let's just see what happened. Over here download job is created and all that stuff is happening. The validation is done, and the file is downloaded. This is the download time, the download size. Okay, let's just keep going. Okay, so over here it says that installation is done collecting result, and the IP exit code is this, and IP code is defined as soft reboot, which is what I sent over there. Device restart behavior, close handle, and then detection rule is going to run again, and over here it downloads the .ps1. There is that toast notification, and if it is collecting result, and over here this is what we see. So this is the after behavior. So over here you see this is the before and this is the after again. So before, and this is after. This is before and this is after what the PowerShell script detected during the when the detection manager ran it for detection. So over here you see that before the PowerShell exit code was 1, and after it was installed, when the detection logic ran again, the exit code was 0. Right? Or am I looking at the IP exit code? Okay, this is what I have to look at. My bad, I was looking at the wrong sentence. So earlier the IP exit code was 0, which means that the PowerShell script ran successfully. Later on the IP exit code was again 0, which means that the PowerShell script ran successfully. Obviously it ran successfully in both the cases. What was the output for the first run? The first run was exit code 1 for PowerShell. In the second run the exit code was 0. And what is it that we have defined in our PowerShell script? So if I go into temp, this is what we have in the PowerShell script. So when the KB is found, it should exit with 0, right? So the KB was found in after, therefore it exited with 0. When the KB was not found, it exited with 1. Okay, so this is what we have to look at, the PowerShell exit, right? So and if I go into the portal, then obviously in the portal this is going to show under managed apps that the application was installed successfully. Right now over here it says that waiting for install status. Maybe it will work for some time, and then over here it is updated, which says that the app installation was completed successfully. So I mean, what I wanted to show you guys is this is how we deploy a KB. And this is again very useful because in Windows update ring this is something that we don't do, and this also shows us how exactly a PowerShell script can be used for detection logic. Same can be used for the requirement rule as well, right? Okay, and the next part is I wanted to show you guys a little trick that is from Oliver. So let's just say that right now, as on this moment, this machine has got one Win32 app installed, right? It can be any Win32 app. It could have been Chrome, it could have been Firefox. In our case, it happens to be the KB, right? So let's just say that it was a LOB application or something like that. And so all we did was we went into the Intune portal and we uploaded the KB, right? We uploaded the patch and it's coming down to the device. But what if I uploaded it and then I forgot where the KB was or where the patch was present, right? And so if it is a patch, the patch can be downloaded from the internet. But what if instead of that patch, it was a LOB application? So that LOB application cannot be downloaded from the internet, right? Now let's just say that we need that LOB application installer again. Let's just say we want to make some changes to it. We want to see what that installer is doing. How do I get that? Because in this machine, that installer is already installed. So there is no way of me to get that installer file again, because whenever that installer file is downloaded, as we have already seen in the IME logs, all the old folders are flushed out, right? So whatever temp folders there were wherein the files were getting downloaded and downloaded during the installation, during the interim, all of them get flushed. So how do we take care of that situation? So there happens to be a article and a tool that Oliver Kiesselbach has written on this, and this is what I'm going to make use of. So if I refer to this article by Oliver, so over here what he says is he has written a script. So what I'm going to do, I'm just going to copy this script. And if you see closely here, what the script is doing is this script is actually calling a file called Intune WinApp util decoder. So until now, we have been using the Intune WinApp encoder tool, which was converting a normal.exe to a Win32 app file. However, there is a decoder.exe as well, which I believe is present in Oliver's account. So all we have, it's present in his GitHub account. All we have to do is hit this link and then download this utility, this WinApp util decoder.exe. That's what I have done until now, and I have copied this script. So now I'm headed to my machine, and if I go to my machine, if I go to C drive, if I go to temp and my folder, over here you see that there is this script present, which I just copy pasted from there, from the URL. So it's the same thing. I've just copy pasted the same thing. The only change that I have made is this line was actually commented. What I mean by this line was commented is, if I go into this script, you see that there is this hash, right? Which means that this is an optional call, and he has commented this line. So what we are going to do, we are going to remove this hash so that this line actually gets processed in our script. So all that I've done is just remove that hash from front of that line, and I have downloaded that Intune WinApp util decoder from Oliver's GitHub account. Right now, I have opened up a PowerShell script, a PowerShell console, and I am running this terminal as an admin, as you can see over here. Now I have browsed to this location, C drive temp EI, and then the first thing that I need to do is I need to set the remote execution policy to unrestricted so that I can run a script. I've already done that. Now all that needs to be done is I need to run that script. So let's just run this script.ps1, and this is what the script did for me. This script first downloaded that file, downloaded a .temp file. What that temp file was, we'll talk about later. And then that decoder tool that we have over here, this decoder tool decoded this temp file. So what we'll do is we will quickly go to this location in this machine. Sorry about that. Let me just copy this. And if I go over here, and the file that I'm looking for is temp b6 5f. So let me sort by, okay. So we see that there are two files with the name temp b65f. One has an extension .temp and the other has an extension .temp.decoded. This was the file that was downloaded, and this file was then decoded using that decoder util.exe, and this is the file that we have. So what is the content of this file, right? That is, why are we actually doing this? So what I'm doing is I'm copying both these files to desktop, and let me just do this. Let me just rename both the files to .zip. Okay, was it done? No, I don't think it was done. Let me just copy both these files to my host machine, and this is wherein I'll be doing it. Let me just delete this. Let me just delete this. These are the two files that we have. So this is the decoded file. Let me just rename this to .zip. I just want to open this file and see the content. Therefore, I am converting this to a zip. Okay. So you want to rename decoded to yes. Okay. All right. So now if I open the first one, this is the error message that comes up, which says that the file is invalid, right? Because this file is not decoded yet, and that is what Oliver's article also says, that if you try to open up the file normally, then this is the error message that you'll be getting, whether you use 7-zip or whether you use whatever tool. However, the decoded file, if I open this one, then if I just open this file, this is the content of that file. That is, it contains the .msu. So instead of .msu, if it was .msu was my input file, right? This is the file that I used to convert to .intune win. So if I had a .exe, that is what I would have seen over here. If I had a .msi, that is what I would have seen over here. So what that tool did was, that tool converted it backtracked. So it in a way converted the .intune win file to .msu, or it will convert the .intune win file to .exe or .msi or whatever the case is, right? So this is just a quick little trick for us if we want to recover the file, and the intent here is, why do we need this? Well, the requirement here is, I as an admin, when I created that policy, I uploaded that .msu to the portal. Now if I have left that organization, then there is no other way the end users can, the new admin can see that .msu or the installer setup file, right? So this is a method by which we can do this. And the other thing that I wanted to show is the registry location. So if I go into regedit, then this is the registry location that gets populated for a Win32 app. So in our case, let's just quickly make a note of the app ID. So this was the application that was installed, and the app ID is ending with is 8C ending with ed. So if I go into the machine, this is the user ID and this is the app ID. So you can see it's starting with 8C ending with ed, and it's present inside HKLM software, Microsoft IME Win32 apps, and that is the key node, and then there are other nodes as well, right? So, and this is all the information that is there with relevant to the application. So this is the user and this is the app, right? So this is something that you might want to take a look over. Okay, and guys, the last thing that I wanted to show you was a little bit about the detection logic that we are using and collecting the logs remotely. So let's just say that, we have already seen this in the presentation, so I'll make it very quick. So let's just say that what happens if we are using an incorrect detection logic. So if I'm deploying Chrome, and in that case, let's just say that the path that I have put in is C drive temp, which is not going to be the case before Chrome got installed or after Chrome got installed, right? C drive temp is never going to have this file unless I place it manually. This is the only change that I am making. And the expectation here is that the application should get installed on the first attempt. However, on the second attempt, what I mean is when the detection logic runs for the very first time, it's not able to find C drive temp chrome.exe. Therefore, the detection logic says that application not detected, Chrome should get installed. After Chrome is installed, the detection logic runs again. It's still not able to find. Therefore, it reports that the app was installed but was not reported. So just wanted to quickly show you guys whether that is the case or not. And then probably we will try to remotely collect the logs. Right, so let me just go to the other user and then test at the rate everything about intune.com and then the password, and then we will I believe the device is already joined, and then we will wait for the Chrome application to come down, install, and then we will see what exactly is the behavior. Okay, ESP is coming up, that's fine. So one quick way of triggering the get policies is by restarting the service. So I'm just going to restart the Microsoft Intune Management Extension service, which should just speed things up for me. And I believe that appwiz.cpl, let me just make sure that Chrome is, I know that Chrome is not already installed and IME is there. So let's just wait for the Chrome installation to begin and then we will resume. Okay guys, so now we are back at the machine and it seems that Google Chrome is installed, and we are able to see the shortcut as well. And if we see the notification, it says that IT department, the first notification, toast notification, the second one downloading and installing, and the third one is EI Chrome installation failed, even though Chrome is installed successfully. And this is what we were expecting to see as well, given that our detection logic says that there should be a file inside C drive temp, which is not the case, right? So now let's just quickly take a look over the log file. So I'm going to go to Microsoft and then Intune Management Extension, logs, and then client agent management log. What I want to show you guys is how to collect the logs manually if the need be. So let me just, again, I will read through the log very quickly, even though we have done this so many times and we know what we are expecting to see. So first time the detection should fail because obviously under C drive temp it was not installed. Obviously under C drive temp no file were present, and after the installation is done, over here you are seeing that start unzipping and all that thing is happening. So I'll just scroll very quickly below, and after the installation is done, then the detection should happen again and the detection should fail. And once the detection fails, because it should check for C drive temp, and if that is the case, then it should report to the Intune service saying that file was installed but could not be detected.
So let me just go to devices and then this device, and then only if it loads up a tad bit faster. Okay, if I go to managed apps, then this is the application EI Chrome, and now over here you see that I have an option called collect logs. This is only there when the app installation fails. Okay, in our case the app installation has failed, therefore what I can do is I can collect the logs. For me to collect the logs, what I'll do is I'll click on collect logs. I'll provide the path over here, logs slash, and then the name of the file, which in this case is this, right? And then enter, and then I'll do a OK. And over you see it says initiating application log collection. So the IME is going to take care of that, upload the logs from the device, and then once it has been uploaded, then after a couple of minutes you will see that this option is not grayed out anymore, and I have an option of downloading the logs from here. So once I have that, then I can download the logs, and the same logs which we copy pasted from the device itself. Okay, it says initiated over this. I'm expecting to see something like completed. So instead of reaching out to the end user, we can get this done ourselves. So we are not reliant on the end user to provide us this information, right? Okay. Okay, guys, and the final bit of information that I wanted to provide is about IME. So this piece of information is very useful because you won't find it in any of the documentation as of yet. So until now we have said that, you know what, when we deploy a Win32 application or a PowerShell script, IME gets installed, right? That is, main tech guy goes there automatically, right? But how does IME get installed? That is also an interesting question, right? We know that IME is an agent. It is our remote hand, as we spoke in the beginning of the Nugget. But then where is the IME getting downloaded and installed from? Because it is something that we are able to see in the control panel, right? We are able to see IME over here, which means that it is like a agent. And if it is an agent, then the agent needs to be installed. If it needs to be installed, and it needs to be downloaded. So where and when did the IME get downloaded and installed from? And it's a very valid question, right? So the way this works is the very first thing that happens once we are deploying the device, once we are deploying a Win32 app once we are deploying a Win32 app, or once we are deploying a PowerShell script, is this registry gets created. So under computer HKLM software, Microsoft Enterprise Desktop App Management, you will see that under MSI, this key will get created. Okay, you can think of it like if you have deployed any MSI, this key gets created. Right now we have not deployed the Intune management extension MSI, but still just think of it like once you're deploying a Win32 app or a PowerShell script, the first thing that gets deployed is a MSI. What is that MSI? That MSI is the Intune management extension. Okay, so this is the so you will see this key over here, and this is the information of that key. So all this information is present over here. The important thing that we need to keep in mind is over here we have something called current download URL. Okay, so what happens is there is a service that runs in the device called background intelligent transfer service, or the bit service, right? This service is responsible to make sure that whenever the device is reaching out to any remote server and downloading any content, then the network is, it makes sure the network is throttled, right? It's not, just make sure that there is no network related impact, and it takes care of all the downloading stuff, right? So this bits service is responsible for reaching out to this content download URL. So it will reach out to this content download URL, which is this URL. Okay, what is this URL for? Let's just hit that URL and find out. So let me just go to Chrome and let me just enter this URL and see what is happening. It automatically downloads a MSI. Okay, what is this MSI? We are going to very soon find out once it finishes download. So let me see here. If only it was any faster. Okay, I think it's downloaded now. So I'm just copying this and pasting it in the desktop. Okay, so this MSI is what the bits service is referring to. And where did it get this MSI from? By referring to this registry location and getting hold of this URL. We don't need to manually provide this URL. This URL is auto-populated depending upon the MSU and depending upon where the tenant, which data center the tenant is located physically on. This will get automatically populated, and once you hit this URL, the Intune management this is the Intune management extension, MSI. Okay, how do I prove that? I prove that by doing this. How about so this Intune management extension got downloaded and installed automatically, right, when I targeted the Google Chrome application. So how about I uninstall this application? Yes. And how about I go to C drive, program data, Microsoft, Intune management extension, and I delete this. And I go to C drive, program files, Intune management extension, and I've just renamed this to old 123. Okay. So this is equivalent to us not having the Intune management extension on this device, right? So what happens if I run this installer now manually? If I run this installer now manually, it is equivalent to the Intune service pushing the Intune management extension. So this is what is happening automatically for us. If I refresh the screen now, you will see that the Intune management extension is now installed. And if I go to C drive program data, you will see that the Intune management under Microsoft, you will see that all the folders are populated and the logs are getting created. So the point that I'm trying to make is the way this works is whenever we deploy a Win32 application or a PowerShell script, the first thing that will happen is in the registry under Enterprise Desktop App Management, this registry key gets created as a MSI, because you can say that in a way the first thing that gets targeted to the device is the Intune management extension MSI. Okay, and over here the URL is present. Bits service grabs hold of this URL, and I mean in a way it references this URL, which is, I'm sorry about that, which is equivalent to and you know why these prompts are coming? Well, I'll come to that later. So so the bit service references this URL, and the bit service downloads the Intune management extension and then installs it. So just what we did manually by going to this URL, double clicking, installing it, the bit service is doing that for us. Once the Intune management extension is installed, then Intune management extension takes over, right? The Intune management extension service is also created, and then IME will do the get policies, and then it will do whatever it is supposed to do. But the point that I wanted to make here is explain how does the Intune management extension gets downloaded and installed, what exactly the Intune management extension is, because until now we were saying that it's just an agent, and which is visible in atlas.cpl. So if it's an agent, then it needs to be installed, and this is the setup file for that agent. And if I want, I can deploy this MSI also from Intune. So we have an option of deploying a MSI as a LOB application from Intune, right? So let's just say that there is an issue wherein the MSI is not getting automatically downloaded by that URL. So what I can do is I can push this MSI automatically from Intune as a LOB application. Now, again, not really needed. I'm not going to talk about the use cases of that. The other thing that I want to speak about very quickly here is over here we see that this is the location and then this is the URL, right? This is the URL, and this part of the URL is actually, I won't say tenant specific, but what I will say is it is the so let's just say it this way. It would depend upon in which data center your tenant is actually located in. Okay. So and this part is documented. So if I go to the documentation from Intune, which says that what are the network requirements, this is the landing documentation for Intune, right, which says that I mean, if you have worked with Autopilot, this is what you would have referenced, right, to whitelist endpoints so that device is able to communicate with the Intune service. It talks about all the IP addresses that needs to be whitelisted if you're in a corporate network. So over here there is a section that says that network requirement for PowerShell scripts or Win32 app. So over here you see that there are 3 URLs, and these are the CDNs. And these so there, you can think of it like this way. Again, it's a very vague example, but think of it like this way. There are 3 data centers for Intune, and your tenant can be located in one of these data centers. Depending upon which data center your tenant is present on, the URL, the appropriate URL will be used. So for example, in my case, it was this, the first one. right? The first one, this one was in my case. However, there is something called secondary and there is something called hotfix as well, right? There are other locations as well. So you can refer to any of these. I mean, the bit service can reference a URL and that URL can be any of these three URLs and the output is the same. What I'm trying to say here is, without confusing anybody, this is the URL that we had, right? So how about I go to run and the first one is what I had. What about if I copy this and I change the URL now to this, right? So instead of referencing this URL, now we are referencing this URL, right? What changes? Well, actually nothing. So what I'm trying to say here is, if I now go to Chrome and I hit the same URL, it will again download the same Intune management extension MSI, right? Which will, so if it was being done manually, same thing would happen. If it was being done automatically, then in the registry location you would have seen the other CDN, and if there was the other CDN, then it would download the same package. So you can think of it like this way, that depending upon where our tenant is, there are three locations and the Intune management extension will be downloaded from either of these three locations. So the intent here is letting you guys know that how exactly Intune management extension or the remote hands gets downloaded, gets installed, which registry it references to before installing it, right? So once this is done, then the IME registry will also be created. The Intune management extension is also extension registry is also created, and then it takes over. But this is how the CDN comes into the picture, and this is how IME gets downloaded and installed, right? So that's pretty much it, guys. I hope that I was able to, in this in this one of the longer ones, demonstrate and discuss all the things that we had in agenda and a few little tips and tricks. So the key takeaway from this nugget should be understanding the importance and the power of Win32 app deployment and what all we can do using this technique, why this one is very important, why this is the real game changer. And if we are to actually deploy a PowerShell, not exactly PowerShell, there will be a different one on PowerShell script, but if we were to deploy a Win32 application from Intune, then what is the processing that we are expecting to see in a working scenario? That's pretty much it, guys. I hope that this has been informative for you. I would like to thank you for viewing. This is your friend Saurabh Sarkar signing off.